Dr. Ram Prabhu joined Director and Scientist, DRDO, and Dr. Sonu Sen, Assistant Professor, Department of Physics, Shri NK Government PG College, Khandwa, MP. Now, uh, now, I will request our Honorable HOI Sir, Dr. Lalji Prasad Sir, to welcome our keynote speaker.
Hello. May I audible?
Yes, sir.
Yes, sir, you are.
Yes. Thank you very much, Madhumita ma'am. On behalf of Sage University, I, Dr. Lalji Prasad, welcome to today expert Dr. Ram Prabhu, Joint Director, DRDO. And we, along with the all participants, definitely we will learn a lot in respective of your subject area. And today topic, functional graded composite for aerospace. Thank you very much, Dr. Prabhu, for acceptance our invitation and provide your valuable time.
All right. Thank you. Thank you. So shall I go ahead?
Sir, before starting, let me introduce about your.
Okay. Go ahead.
Good evening, everyone. Dr. T. Ram Prabhu is distinguished scientist and joint director at DRDO, Government of India, with over 15 years of research experience in engineering design and material science. He holds a PhD from IIT Madras and an ME from ISC Bangalore. Excuse me. Okay. Dr. Prabhu specializes in advanced manufacturing processes, metal additive manufacturing, and materials engineering for aerospace and defense applications. A recipient of numerous prestigious awards, including the DRDO Chairman's Gold Medal and Lifetime Achievement Award for Metal 3D Printing contributions, Dr. Prabhu has made significant technological advancements for India's defense sector. His session will offer valuable insights into innovative materials and advanced manufacturing techniques in the automotive and defense industries. With this, I request Dr. Ram to start the session. Dr. Ram, sir.
Thanks, sir. Thank you so much for the good introduction. So let me get into the slides.
Yes, sir.
Hope the slides are visible.
Yeah, yes, sir.
So is it moving, sir?
Yeah. It's
Slides
okay.
are moving?
No issue. Yes.
Okay. So, sir, I also request all the participants to get muted because sometimes, some people, unmute and talk something inside in the middle of the presentation. So please make sure that all are, muted.
Yes, sir. Sure, sir. I will take care of that. No, don't worry, sir.
Yeah. Thank you. So for next 1 hour to 1.5 hours, we will talk on functional graded composites in the perspective of aerospace application. Before I just touch upon the aerospace applications, let me introduce you about the topic, what is functional graded composites, how you can exploit this concept in various applications across the spectrum of applications. So let's understand what is functional graded metal matrix composites. So I'll focus mostly on the metal matrix based composites on functional gradation. Okay. So the idea here is you will not have a homogeneous material. So take it metal or alloys, they all are called the homogeneous material. How I can make it heterogeneous? There are variety of ways. So adding the second phases, non-uniformly make it heterogeneous material. So functional graded is one of the concept to get you the heterogeneous structure in the material. This heterogeneous structure we intentionally introduced to get the certain contrasting properties to be optimized in the material structure. So to put it very simply, we change either the composition or the phases in the microstructure, which will change systematically over the volume of the material. So that is the way, we make it. For example, you take our human bone. So if you look at the human bone, structure, especially it's the porosity is present inside the human bone structure, it is functionally graded. Is one of a classical example for the functional gradation in the material. And if you ask any mechanical engineer, they say we have a gear material which is having the phase changes across the section thickness. Like if you look at the top surface, it will be very hard with the martensitic structure, and it gradually changes from martensite to the typical tempered or the perlite structure to have a better toughness. So hardness on the surface, toughness at the core, kind of a contrasting property I optimize in a single material through the phase gradations. So these are the called the functional graded concept in any material. So why do we need that? If you just delve deep into that, there are properties in any materials. You take it any kind of applications which demand certain properties, and some of the properties are typically paradoxical. Like when you try to increase the strength of the material, its toughness goes down. Similarly, ductility goes down. When you try to increase the wear resistance of the material, uh, friction increases. And ultimately, you need a material which has a low friction and high wear resistance. So both are contrasting in nature. Like there are some applications need to have good thermal conductivity also, at the same time thermal stability also. Take an example of ceramic, has a very good thermal stability but doesn't have conductivity at all. Same applies for the electrical conductivity, magnetic permeability, coefficient of thermal expansion. Okay, so when I put two different ingredients into the material, which has a wide difference in CTE, which introduces the thermal stress in the material, leads to the cracking or any kind of problems. So when I have those kind of structures where I need the optimization to be done to ensure that my material is intact. Okay. And other properties in the physics domain like refractory index, or in the navy domain corrosion resistance. So where if you see that I need the contrasting property to be optimized, and I want both the properties should be high in the same material, which cannot be obtained by the homogeneous material. That's why we go for the functional gradation. So this is the very basic concepts. I want all the audience to know why we go for the functional gradation. Next question will comes to your mind: what are the different type of functional gradations? You take any material,
Excuse me, sir. Your slides are hanging, I think. Is there any technical issue, sir? Gautam, sir? Am I audible?
Yes, sir. Audible, sir.
Yes.
Maybe. Okay, thank you. Maybe some
Am
technical
I
issue.
audible?
Yeah, yes, sir, audible. Actually, slides are not visible only.
Yeah, 1 minute, sir. Just got
Okay,
power disconnected. Just a
okay,
second.
okay. No issue, sir.
How about now?
No, slides are not
Not
shared.
it. Not it.
No, sir.
Okay, 1 second. I'll share it. How about now,
Yeah,
sir?
sharing.
Yeah.
Not visible, but it shows sharing. Double click to enter. Yeah, okay. Still there is some problem.
Some network issue, maybe.
Maybe. Sir, rejoin, I think. Sir, you need to unmute first.
Am I audible now?
Yeah, perfect, sir.
Okay. Now I have to share the presentation.
Yes, sir.
Yeah. How is it now? Visible?
No, sir, not yet.
Slides are not visible.
Yeah, now it's visible.
Is it moving?
Yes, sir, yes, sir.
Okay. Sorry. There is some
No,
power
no, sir, no
interruption.
issue.
Yeah. So you understood what is functional gradient concept. Now there are two type of gradient you can introduce into the material. One is continuously varying. It's like a linear. You take a function of y equal to mx plus c. Similar way, now across the thickness you can vary the one particular phase or one particular composition. For example, you take aluminum silicon carbide composites. Silicon carbide amount I can vary, the volume fraction I can vary from the surface to the core continuously. That is called the continuous variation. Like at any instant or at any particular thickness, the value of the any particular thickness with another thickness may not be same. So that is called the continuous. Discrete means it's like imagine a steps. Okay, you have a stair steps. So it's like a step by step you vary. Up to certain thickness, you'll have one composition. When you go to the next thickness, you will have a certain composition, similar different composition. Then the third, domain, you will have another certain composition. Likewise, step by you vary. It's called the discrete graded composites. So there are two ways you can manufacture. And if you want to make the continuous gradient, you can use the centrifugal castings. If you want the stepwise, gradient, you can use the powder metallurgy techniques. Okay. Why do I do research on this area? If you ask me, whenever I have any applications which undergoes the combination of the thermal and mechanical loading, you can very well see that even if you do some ANSYS simulations, FEM simulation, you can see that superior performance of this heterogeneous structure over the homogeneous material. Okay, the reason is you don't have sharp interfaces in FGM. Okay, that leads to the very more uniform stress distribution, which enhance not only your strength, also delays your crack propagations or the initiation, leading to the improvement in the toughness of the material. Okay, and coming to the thermal area, when you have this kind of a systematically graded structure. This will better accommodate the thermal stresses, reducing the thermal shock failures in the materials. Okay. So today I'm going to talk about on functionally discrete graded composites for aircraft brake applications. This can be applied for automobile also. Before I get into that, for the interest of all the audience, if you guys are, I know that different department engineers are scientists are sitting over in the class, or faculties are sitting over in the class. For them, I just want to give you a comprehensive overview of what are the applications where you can apply functional graded composites. Okay. So first and foremost is if you are interested in space, enclosure, that is a heat shield, where you need a thermal barrier coatings, okay, to protect this spacecraft. Similarly, in the gas turbine engine blades, which undergoes a very high temperature. So conventionally, people use the thermal barrier coating. The problem with the thermal barrier coating, you have a metal, on top of it you apply the ceramic coating. So metal and ceramic, at the interface, it's a sharp interface change from metal to ceramic, leads to the cracking at the interface. Okay. So if I change that sharp interface to the gradually varying the interface, like from metal to the ceramic, then you can better accommodate the thermal stresses and the mechanical stresses. So no cracking are expected, or the life of the coating will be higher. So that is the bottom line why functional graded approach is very beneficial for thermal barrier coating. Then people who are interested in bioengineering or biomedical area, dental and orthopedic implants. Okay, naturally this material, our tooth or the bones are the functionally graded structure. Okay, if you look at it, bone which is made up of ceramic plus polymer, and which has a degradation. In addition, you have a structural gradation like a porosity gradation. Same goes for the dental also. So these dental and orthopedic implants development, you can apply these concepts. And if you go to the military, okay, so all our soldiers, they use the armor plates, bulletproof vest, and they need a lightweight one. At the same time, they need a very strong and tough also. Strength and toughness both are needed in this. Like if any projectile hit on them, it should not get penetrated, because the projectile hits on it, it should not crack the surface, so the life will go down. So you need to have a good energy absorbing capacity, in addition to have a strong forbidding capability of the like your bullets. Okay. So you need to inbuilt the properties of controversial one or a paradoxical one, strength and toughness. So there, this functional graded approach will be worthwhile to examine. Then for the physics, electronics people, the refractive index is a very important property used in the optoelectronics. Also, you can introduce the material which has a different refractive index and improve the performance of these electronics and the storage media applications. And who are into the hardcore mechanical, especially in the machining, they understand very well. We use the cutting tools, either high speed tool or the tungsten carbide and cobalt kind of a cutting tool inserts. These needs the coating where you can introduce the functional gradations. And similarly, in the automobile engine, we have several high temperature exposed parts like piston rings and so on, where this functional graded has a significant advantage. And people who are into the instrumentation electronics, you often come across with the sensors and actuators. Either sensor material or the actuator material can be designed with a functional graded approach, or the coatings for them can be designed. Then comes tools and dies which are used for many manufacturing processes, conventional like castings, forgings. Take it any manufacturing process, tool and dies are a very important one for the traditional manufacturing. So there also, to improve its life, we can introduce the functional graded approach. And civil engineering, whoever makes any robust structures, if you want to prevent the earthquake, or if you want to create the structure which can withstand the very high earthquake, where we can incorporate, both the controversial properties like the stiffness and damping capabilities we can build into your structures. And lastly, clean energy and the renewable energies are given very much important by the government of India. For example, the solar cell research, where you need a thin layer, photovoltaic cells, which can be made by the FGM, that is a functional graded approach, to overcome its theoretical limit of 20% efficiency to push it to the further for the compared to the homogeneous materials like a silicon. So there we can use this functional graded approach. The reason why I wanted to show these slides to everyone, when you take up any research problem in this domain, you should figure out the specific application what I mentioned, and you should start your research in this specific application and direct your research to benchmark the existing material used in these applications. Then only your research will be useful, not only for you, for the industry, as a general, for the country. We do the very effective and useful R&D research in the academics if you channelize our energy in this kind of a application oriented functional graded approach to the application oriented research. Yeah, so let me get into my research work on this, which had done some 10 years ago. Just to give an idea, sir, what time I should close my talk, by the way? It's now 6:40.
Sir, it's up to 7:30.
7:35.
Yeah, yes.
Yeah. So coming to the aircrafts, this is a typical aircraft brake system. You can imagine your automobile brake system, two-wheeler brake system, or the four-wheeler brake system, similar line only, but it is all this is axial brake. Okay, you have a stator rotor combinations, and rotors are generally made out of cast irons. Stator is fitted with a metal matrix composite brake pads, conventionally currently used in majority of the aircrafts, especially in the military domains. Okay, if you go for the civil aircrafts, people go for the carbon brakes, because it's a very huge aircraft, and number of passengers and the fuel consumption, the energy level is very high in the civil aircrafts, whereas in the military aircraft, you hardly have two or three humans inside. The pilots, either the two fighter pilots or the three fighter pilots or the single fighter pilots typically you have. So energy level is very less relatively, but the performance characteristics needed by the military aircraft is phenomenally higher than the civil aircraft, because civil aircraft is just take off, cruise, land. That's all. Just a trapezium curve. If you just imagine, just a takeoff, sloping up, horizontal line, sloping down. That's all. So there is no complex maneuver. There is no complexity in landing in takeoff or landing in the aircrafts. Whereas in the military scenario, I don't have a luxury of takeoff distance or the landing distance. I may need to land in the ship deck. I may need to land in a place where I have a very short runway. Such a kind of a very harsh scenario is experienced by the fighter pilots. So I need to have very nimble brake system or the brake pads to have a very effective braking in the calamity situations or the war scenarios. So why I emphasize this fact? Because military aircraft's brake units are more complex and needs extremely high performance. So now conventionally metal matrix composite is used, either iron based or copper based. Okay. Just to give an idea, what is a typical energy a brake unit has to absorb in a typical military aircraft is somewhere around 4 to 16 megajoule, 10 power 6 joules. Okay, depending on the payloads what I have. So I may have an extra drop tank, stored fuel, or bombs or missiles or rockets or any kind of ammunitions like guns and so on. So these all payloads increase my mass of the aircraft. So what is the kinetic energy of mv square? And the velocity, I typically go in the supersonic speed, or at least land in this sonic or subsonic speed. So of mv square, just put it velocity square under the mass, so you can understand. And typical runway distance is less than a kilometer. and I have a time about a half minutes to land my aircraft due to the limitation in the runway. So my brake application speeds typically around 300 kmph maximum, and I cannot have a very big brake system. So I can use a huge brake pressure to apply the. I can generate the huge brake pressure. I can apply the brake and I can stop the aircraft in a shorter distance. But I don't have that luxury, because if I have to create the huge brake pressure, I need to have a more accessories, big compressor units, so that occupy the space, and that will add the weight of the aircraft, and that will put a restriction on my payload. When I go for the war, I need to have more bombs, more missiles, more rockets. Then having these kind of subsystems or the systems occupying my weight. Okay, so I have space constraints, I have weight constraints. So putting all these together, I need to have a very compact brake system, high with a high performance. So that is a functional point of view. Coming to the material point of view, as you know, just you rub your hands, you can very well understand that heat is generated due to the friction. Now look at the rubbing the hands, you just understand how much is the kinetic energy you spent on it and converted into the heat. Now look at the aircraft, similar way, I apply the brake at the speed of 300 kmph, half m square. If you put that energy, I will be converting into the heat. So typical heat generation at the interface will be somewhere around 650 degrees Celsius. So no aluminium, no magnesium kind of a lightweight material can withstand, because its melting point itself 660 degrees Celsius. So at the same time, if you rub your hand, if you don't have conductivity at the interface, your skin will burn. So I need to have very high conductivity so that heat can be dissipated. Second important property is specific heat. Okay, so specific heat means how much energy I can absorb, okay, or how much energy is required by the material to increase its temperature to 1 degree Celsius. So if I have high specific heat, I need to spend more energy to rise the material's temperature, right? So I need to have high specific heat. I need to have high melting point so that no material doesn't soften. I need to have a thermal stability, and since it's a metal matrix composites, I have a metal, I have a reinforcement. These two should not have a high mismatch of coefficient of thermal expansion. If I have high coefficient of thermal expansion mismatch at the interface of your particle and the matrix, there will be a high stress leading to the cracking at the interface. Then your whole idea of fiber reinforcement fails. Okay, and most importantly, I need to have a stability in the friction coefficient. If I don't have a consistent and controlled friction, I cannot ensure the stopping distance or the stopping time. Okay, so I need that. And from the life perspective, I need to have high wear resistance so that I have high life. I mean, I don't need to frequently replace my brake pads. So for that, I need to have a high surface hardness and strength like compressive and shear, because when I apply the brake, it is in the motion in the forward directions. And when I apply the brake, it is a compressive force. Because of the motion, there is a shear at the interface. So shear strength also, compressive strength also should be high in the brake pads. Now let's look at it. What is the problem in the conventional brake pads? So I also want you to look at the problem statement, how we created, okay, how this research is useful for our country's innovations in the defense. You guys are also doing the research, whether is it making any mark, you please think about it. And these all the research is done with a very minimal facility. So looking at the copper or the iron based brake pads, biggest problem what I said is at high energy, at high friction, huge temperature is generated. So there is the oxidation at the interface, leads to the brake fad, means loss of coefficient of friction. In other words, I need to have a longer stopping time or the stopping distance to stop the aircraft. It is nothing but the loss of braking effectiveness. And higher temperature also soften the material, affect the life of the brake pads. Okay, what I can do? I have to increase my thermal stability. I have to increase my braking performance. So these two are contradictory to each other. So what we thought, can we introduce the functional graded approach in a stepwise by introducing the composition by introducing the particle size. Okay, so by introducing the composition, I created the macro structure toughening mechanism. When I show the images, you'll be able to understand what I mean. And when I introduce the particle size and the composition gradient, I can create the better path for the heat conduction. If I have only a composite, the conductivity is poor. If I have a metal with the composites, a better conductivity will be ensured. And by having this particle size gradient, I can ensure the better load, contact load distribution. Though whatever the brake pressure I apply, it will be uniformly distributed across my brake pads. So this is the fundamental idea what we thought. So we have implemented in our brake pad by building layers by layer structure. So you can call it as a laminate, or you can call it as a discrete functional graded composites. Okay. So our idea is to implement this idea into the copper based brake pads. So the material taken matrix is copper and silicon carbide. It's a conventional brake pad. Copper, silicon carbide for the load sharing, graphite for the as a solid lubricant to stabilize the friction. So this is the way a brake pad is designed. It's called the hybrid composites. Now I'm going to introduce the functional gradation. So how I'm going to do it? So I'll show you in the next slide. So we have developed 5 composites. 2 is my benchmark, the existing composites. 3 is the functional graded composites. All of them have the composition of whatever I showed: silicon carbide, graphite, barium sulfate, tin, and copper. Tin is added to facilitate the liquid phase sintering during my powder processing called the powder metallurgy. Okay, graphite plays a role of friction stability because it's a lubricant. Silicon carbide strengthen the composites, improve the load distributions, and increase the hardness of the material. Right. So just pay attention to this slide. You will be able to understand. Yeah, conventional composites will have backplates called steel backplate. Every composite it will be having, because I have to rivet that to the stator. On top of it, composites will be laid up. Okay, L stands for large size silicon particle, S stands for small size silicon particle. This is my benchmark, existing one. Now what we did, why can't I introduce 2 more layer between the steel cup on the top surface? That is L mix or S mix. So one is just to introduce the matrix itself. That is the key here. If I introduce some other metal, I may not achieve the desired property. So I introduce the pure copper here. Now I have L small size particle, large size particle. So why can't I put small size particle composite as a 3rd layer, and the top layer will be large size, and I flip it off. 3rd and 4th layer I interchange it in the type D or the figure D. In figure E, why should I do small size, big size as a gradation? Why can't I mix it and make it a bimodal composites? So you have a pure layer on top of it, bimodal. So you can see from the figure C and D and E, there is a composition variation. So if you see the silicon carbide amount in the pure copper layer, it is 0. Whereas if you go to the S or L, it is 20%. Same goes for D also, same goes for E also. So this is nothing but the composition gradient. And when you look at the figure C and D, large size L mix, S mix means large size particle, small size particle. So I have 2 layers of different size of the particle, nothing but the size gradient. Okay. So now I introduced both things in C and D, whereas in E I have only composition gradient. Now let's look at its performance. A typical powder metallurgy, a simple setup is used. Conventional way of mixing it, compacting it, sinter under the pressure sintering it. Then again I repress it to close any surface porosities or any residual porosities retained in the sintering. Then machine it and fit it into the aircraft. Before fitting to the aircraft, we do a lot of tests. So one of the tests, what are the tests we typically do in characterization of the brake pads? As academicians, you are expected to work in a TRL level problem, technology readiness level problem, less than 3. So your job is to just characterize them, develop a brake pad and characterize. That's all. You leave it and tell to the CSIR lab to do the prototype, and tell DRDO ISRO to take it up in the system. Okay. So that is the way in our country the research ecosystem is existing. So for a brake, we don't do like typical your academic research like tensile test I will do, harness I will do. Like there are some certain standard tests you see in any of the academic research. like bend test, 3-point bend, tensile test, harness test, microstructure, SEM. Now recently, because they are unable to publish the paper with this information, they do extra is spin on disk or the SEM or XRD or EBST. Now people are started using EBST to show some colorful images for the publications without understanding why I use tensile test, why I generate this data of EBST and so on. So those are not called research. Those are just like, a layman job. Without knowing, just do something and produce the results for the paper publication series. Research should have an intent. Research should have an application linked. Without that, whatever you do is useless. And whatever the test you are planning for your research should have a relevance to the applications. So if you look at this application, is the brake pad. So what is, we wanted to know whether the gradient is set up or not. So we do SEM and optical microscope to make sure that gradient is set up. Then performance is evaluated by the friction under the wear test called the dynamometer test, or you can call it as a pad and disc dynamometer. And we have chosen 4 different brake speeds and 1 brake pressure or the brake load. These speeds corresponds to the different class of aircrafts. We have a trainer aircrafts, we have a fighter aircrafts, we have a transport aircraft. So to cover all the things, we have selected this braking speed. Second is, yes, I did the experiments. I want to figure out what mechanism is operative at different speeds. So that's called wear surface morphology. So to put it very simply, post-mortem. Take a dead body and look at inside what has happened to that, why the death has happened. So similarly, why wear has happened, we analyze through SEM, XRD, okay, and stereo microscope. And as you know, it's an axial brake. So there is a bending load, there is a compression load. So that's why 3-point bend test, compression test is done. And we wanted to know whether the functional gradation has introduced the hardness variation. In other words, to see that like whether optimization of the strength and toughness property. So we did the hardness test, and the failed flexural test and compression test looked at the we looked at in the fractography to prove that there is a toughening happened inside the material due to the functional gradations. So this was the logic. Based on the logic, these are the tests are selected. Not only that, very importantly, as a researcher, you should understand, I should benchmark it. What is the existing one? That is L mix and S mix. We benchmarked with that to prove that whatever the concepts we did introduced is working well or the providing the superior properties. Right? So we name it as functional graded composite as CSL, CLS, and CBI. BI means bimodal, L means large size, S means small size, C means copper. Okay, L1, S1 is the conventional composites which are currently used. So this is just to prove that you have copper layer. This is a steel backplate, copper layer. Then small size particle region, large size particle region in a simple optical microscope. And our job is to look at the interface. How is the interface, whether it is intact or any cracking is there. Now I want to see all these 4 layers in a single image. So I use a SEM, copper layer, large size particle, small size particle. This is the conventional composites. Only you have a composites and a backplate without any copper layer, just to show that yes, whatever I have done has come or not. Yes, it has come. Now next is, how about the density, whether do I have a densified structure or not. And interestingly, FG composite has a good densification. Okay, one is this high density is attributed to copper layer also, because copper has a higher density. But we also measured its porosity. We see that it has a less than 3% porosity compared to the conventional composites. Somewhere around 8% it has. Bimodal has not worked out. I mean, it is between these two, conventional and the functionally graded composites. In other words, like we have material and particle size gradient. Without that, only if I have only the compositional gradient, that gives the density between conventional and the functional graded composites. Now, to understand the life of the brake pad, we did the wear examinations. So you can see all these 5 composites were tested for 4 different speeds. You can very well see that at all cases, CLS, mean small size particle, then large size particle, then copper layer. That structure gives a very good wear resistance compared to any other composites in the lot. I mean, small size, then the large size, then the copper layer. The small size, because it with the same volume, small size covers more area, so strengthening of the top surface will be very high. That's why the wear resistance is very high. Okay, so small size silicon carbide particle at the surface is very good. Now next is the braking performance. Am I able to stop my aircraft in a distance what I desire? Second is, what is the consistency of the coefficient of friction, like my braking performance over the number of landings. So again, both CSL, CLS performs very good, out of which CLS, that is this one, has a very consistent behavior with respect to the increasing sliding speed. Means even if my energy changes, my consistency is relatively better compared to other composites, especially the conventionally used. And stopping distance also much lower for this composites. Okay, so this shows that CLS composite is superior in giving the braking performance compared to all other composites which we have taken for our study. And the next is the mechanical behavior which is related to the braking application, that is the compression strength, flexural strength, elastic modulus, and surface roughness. Elastic modulus was a calculated one from the load versus deflection curve. Okay, so again you can see this composition and particles is gradient kind of a multi-layer composites or the functional graded composites gives a better compression strength, better flexural strength than existing composites. Surface hardness remains same because in single layer or the multi-layer, the surface composition remains same. So we don't see any change in the surface hardness. Then the postmortem. The postmortem is to understand what kind of a wear mechanism operative at different speeds. So we observed many different things. One is the cracking, vertical cracking, delaminated regions, tribo layers. Okay, you can see very well the tribo layers, and particle protrusions, only the particle pop-ups, some groove lines. Okay, so at low sliding speed we don't see any oxidation or the delamination. Mainly we see the cracking and the groove lines, which is nothing but the abrasion wear. When I go to the higher sliding speed, temperature is very high, oxidation is happening, so good amount of tribo layer also formed, delamination starts coming up, and oxidation wear starts coming up. So low sliding speed abrasive, high sliding speed you have typically oxidation and delamination wear domination in the both the functional as well as your traditional composites. But the intensity of this wear, just to show you delamination wear, this is a sectional view, like you cut the brake pad cross section and look at it. So these arrow regions shows the delamination cracks, okay, which is connecting all the particle and take it up that plow out that entire regions. Whereas in my composites you can see functional graded composites, you can see very well they are thin tribo layers, okay, formed on the surface at higher sliding speed, whereas in lower sliding speed you don't see the tribo layer formation. So that's why in your higher sliding speed you have better wear resistance, whereas in lower sliding wears you don't have it because of the abrasive wear. Then to look at it, what kind of oxides are formed. Low sliding speed we didn't see any kind of oxide formation, which is another proof that abrasive wear is dominant. You can see here. So whatever the elements we have used to build a composites only existing, and some kind of oxidation happened, some kind of reaction happened between copper and tin. But when you go to the higher sliding speed, we can see the number of oxides, iron, copper, barium iron oxides, copper iron combination oxides, and so on. And you also have a tribo layer, so that's why you have a graphite as it is. So this again corroborate the observation of oxidation wear existing at the higher sliding speed, absent at lower sliding speed. fractography. This is a very essential one. So this is the cross sectional, this is a copper layer, this is your composite layer. See, look at it. When any crack forms in the composite layer, it is very drastic and very sudden. You can see like a vertically propagate very fast. Moment it encounters the soft copper layer, you see that branching of the cracks. And if you just expand that branching also, you can see 45-degree angle this guy will propagate. So if you closely look at it here, the crack propagate at 45-degree angle to the loading direction. And when we look at this composite region and the copper region failure, failure, you can see a lot of dimples. Dimples are the typical feature for the ductile fracture. And in composite regions, you have both. It's like a quasi cleavage. Cleavage also, dimple also is there. So composites fails by the mixed mode, fracture mode, whereas copper layer fails by the ductile mode. This shows that because I introduced the copper layer, it increased the toughness of the composites through macrostructure toughening mechanisms. Okay. So this is the proof for improving the toughness in addition to retaining the strength as like your composites. In fact, let a better strength than the conventional composites. So, as a summary, just a quick wrap up. Functional graded composites in terms of densification is better, life, that is a wear resistance, is better, performance like coefficient of friction stability or the stopping distance point of view good. Among the functional graded composites, the one which has the small size particle on the surface is much better than the other two categories. Okay. And the existence of or the absence of oxides shows that delamination wear is dominant at low sliding speed. Presence of oxides and delamination, features shows that oxidation wear and delamination wear are dominant at higher sliding speed. And strength point of view, both compression and flexural functional graded composites are way better than the conventional composites, metal matrix composites. Looking at this layering sequence, it is not much, it doesn't create much difference in the properties, but CLS, that is a small size particle on the surface, is better than the other two categories. And crack branching and crack propagation at an angle 45 in the copper layer is the proof for toughening, macrostructure toughening in the functional graded composites. So in other words, if I put it, the toughness of also composite also has increased in functional graded composite in addition to having the higher strength. Both are contradictory properties. So if you see my first slide in the introduction, if you try to increase the strength, toughness goes down, or if you try to increase the toughness, strength goes down. But having both optimized is only possible by creating the heterogeneous structure like the functional graded structure. So this is the article we published in 2014. One of the hottest article downloaded in the Elsevier journal called BR. It's one of the top journal in the field of tribology. This was selected as the top 25 articles in the BR journal. Okay, so those are research activity which I thought of presenting to you. But what's the takeaway for you from my class? What you can do in future in this area? If you want to do the research, or if you want to do the PhD, or if you want to do the project funding proposals writing, these are the avenues available for you to explore. One is you can introduce the novel reinforcements. Rare earth oxides are extremely important and extensively explored in developed countries, which you can think of adding into your composites and creating the functional graded structure. Second is quasi crystals. Okay, there are a variety of quasi crystals.
Maybe the same problem occurs, I think. Sir will rejoin shortly. Please, yeah. Sir, you need to unmute, sir.
Am I audible, sir?
Yeah, yes, sir. Yes, sir.
And my slides are,
Yes, sir. Perfectly visible.
yeah, slides are visible, I hope.
Yeah, yes, sir.
Yeah. So what are the avenues for you is, one is the addition of rare earth. So this will be a game changer for you to develop a new composites with the functional gradations, or go out of the ceramic, silicon carbide, aluminum nitride, because there are n number of theses are there. Go for some quasi crystals. Through that also you can, you can introduce the functional graded composites and optimize the properties. And the recent trend in the composite area is use of high entropy alloy as a matrix or the reinforcement. So high entropy alloy is phenomenally good in terms of the high thermal stability, or sub-zero temperature also its performance is good. In fact, researchers are currently working on to replace superalloy in the aero engine or the space engines with the high entropy alloy. Now, if you develop the composites, you are in the one step ahead of that. And there are variety of high entropy alloys are existing in the resource sphere, which can be, used to design your proposal or your PhD thesis. And that is one area. Second area where people are very interested is the lightweight materials. Okay, where I need, better strengthening between the reinforcement and matrix and toughness and strength. So one avenue which is still unexplored, significant rare earth elements additions, oxides or the rare earth materials additions. Then aluminum lithium matrix, because they have a very low aluminum lithium matrix. So that also has a very light weight. Then beta titanium alloy, which has a very good creep strength and the fatigue strength. Then, as I said earlier, high entropy alloy matrix. So those areas, if you're interested in material development, composites development, you can work. Processing area, some researchers may be interested in processing this. Additive manufacturing. So one of the latest commercially exploited processes is called laser border bed fusion. And the novel alloys have come called reactive additive manufacturing alloys, aluminum based alloys. 2024 RAM 2 or RAM 10 is one of the pioneering material in the field of additive manufacturing. So these also additive also can be used to develop a coating also, or the bulk material structure also, functional graded structures. Okay. Then friction stir processing. So many research you would have found from friction stir welding and pressure stir processing. This also can be used to create the functional graded structure, surface composites. And third is semi-solid castings, not liquid castings. I mean, you melt the metal and pour it into the mold. You heat it to such a way that both solid and liquid phases are coexisting in the material, and cast it. That's called casting. And coating methods like HBOF or a plasma spray. So by using that also you can develop a functionally graded coating. Okay. And severe plastic deformation area also, you can use that to develop a phase wise gradient structure. And ultrasonic assisted casting, like in the centrifugal casting only, you can use the ultrasound to increase the or decrease the particle agglomeration and improve the particle gradations by introducing the ultrasounds. And lastly, in the powder metallurgy, adapt the hot isostatic pressing or use the spark plasma sintering to have a better densification. So these are the avenues available for you to work on processing of functional graded composites. Then the property aspects, developing a data in tensile or the fatigue load conditions by introducing the notch. Most of your studies are on the simple smooth samples. Okay. Hope I'm audible, right?
Yes, sir. Yes.
Am I audible?
Yes,
Okay,
sir.
fine.
Audible.
So fine, thanks. So none of your structure in any application, automobile to aircraft, none of them are smooth structure. Means you have a structure which has a different radius of curvature. In other words, to put it very simple layman way, stress concentration will be there. However, maybe your structure, a simple structure or a complex structure will have stress concentration. So how do you artificially introduce a stress concentration? By introducing the notch. So notch, by introducing the notch, have you ever studied the tensile properties or the fatigue property or any kind of a properties, which is bulk properties? If you see, the properties will be entirely different from the smooth conditions. So and the quantum of research in that area is very, very minimal. All of you do in polymer composites or the metal composites, just a simple, tensile testing in the sheet or round samples. But if you introduce the notch with a different radius of curvature, the kind of a stress concentration you introduce will vary, resulting into the different mechanical properties. That will be in fact, it changes the, your fracture behavior, like a ductile to brittle. This data will be very, very, very much essential for the designers in designing any kind of a structure. Then studying the property at higher temperature, like a hot tensile or the stress rupture test, and understanding the fracture toughness, like what I showed you in my SEM graph. When you do the 3-point bend test, like when the cracks touches a soft region like a copper region, the crack branching happens, improves the toughness. So those kind of studies. And all of your tensile testing, or the if you do as per ASTM E8, there is a 10 power minus 3 per second strain rate you do it. Have you ever studied the behavior at much slower strain rate or the higher strain rate? And if you look at the data, higher the strain rate, higher the strength, lower the ductility. Slower the strain rate, some material behaves phenomenal ductility. That's what the people call it as a super plasticity. So what is that functional gradation? Graded materials performance or the behavior at slow strain rate or the high strain rate. If you are mechanically involved, you can mechanistical interest is that you can study. Then studying the fatigue property in low cycle mode, high cycle mode. Okay, and if you look at the amount of literature available in corrosion, like stress corrosion cracking or hot corrosion or pitting on the functionally graded composites, are, I would say, very, very less, very scarce reports are available. So there is a huge opportunity for you to explore on the corrosion behavior of functional graded composites. Then, though I develop a composites, some of the composites like aluminium or the magnesium are strengthened through precipitation hardening, or steels can be strengthened by some kind of heat treatment called quenching and tempering. So if I introduce a different heat treatment to the functional graded structure, how the phase formation? Okay. In fact, quenching and tempering is used in the gear to grade, develop a functionally graded phase structure. Then, if you're using the functional graded material in the application like a brake or any rotating parts, any rotating contact parts, it undergoes definitely a wear, maybe abrasive wear, maybe a fritting wear, maybe the high temperature wear. So, understanding its behavior in the tribological conditions is essential. And I talked about the turbine, thermal barrier coating on the turbine blades. This undergoes significant erosion from the fuel particles coming from the combustion chamber. So understanding the erosion behavior is very important. And the new idea, what I seeded in your mind, is the particle size gradient or the shape gradient. Okay, what is its effect on the different properties, whatever I showed you in the property aspects. Lastly, how about the machining behavior, like a surface roughness, if it is high, what kind of a machining studies I should do for the functional graded composites. So if you look at it, like last 3 slides, you can definitely make about 500 to 1000 projects out of it for the various kind of a materials. So the opportunities are huge for the project proposal writing or the PhD thesis in the field of functional graded materials, the functional graded composites in metal alone. Same thing you implement in your polymer or the ceramics. I mean, it's immeasurable opportunities are available for you to do your different theses, like for your undergraduate or postgraduate or PhD. Faculties who have a PhD wants to apply for the funding, You pick up the applications what I told you initial and take up some of the aspects which is interesting to you. Explore for property generation or the process aspects or the material aspects for the intended specific applications. Will be a very fruitful research not only for you, for the industry, in a broader picture for the country's R&D development for the future missions in the space as well as in the defense. So with this, I think my time is 7:20, close to that. So I'll conclude it. So any help you wanted, you can text me in mail or the WhatsApp. I can definitely support you in the field of composites. I do work in the additive manufacturing and other fields also, machine learning and so on. So this area I had discontinued from 2018. Still, I have ideas. So if you are any interested, if you have any interest on this functional graded, I can definitely support you. Maybe for next 10 minutes, we can have a question answer. You can type your questions in chat box or you can unmute and ask me. Maybe in the field of composites or anything on my expertise area like additive manufacturing, machine learning, you can ask. Okay. So
Yes,
over to
sir.
you.
There is a question.
I will read an answer. So let them feed the questions on the chat box. I'll read an
Sir,
answer.
I asked the participants, please unmute yourself and please ask the question.
Everyone option is not there here. So probably you have to give them the access, sir, for the
Yeah,
messages and
access is there already. Dr. M. Shunmung Priyan. Sir, please unmute yourself. Or otherwise, I will read out the question.
I can read just a text the questions. I can read and answer.
Yeah, yes. Just wait, sir.
But I didn't see any questions, so let it come. Then I'll.
Sir, I have sent through chat on the Zoom link.
Okay, fine. Yeah, any composite related papers, it seems like all kind of tests which were displayed in the PPT. It's required that all the tests are necessary for composite materials. Okay, so the first thing is I don't know whether all the tests are done. If you look at carefully my third slide, as I said there, you have to figure out what is the application and the relevant test only should be done, not like at the whims and fancy of doing tensile test, fractural test, and XYZ tests. The minimal requirement is at least hardness is needed, okay, to see that what you have made it. Sectional hardness, not the surface hardness. If it is a polymer, people generally do the flexural test. Okay. But if you ask me, if your particular part application undergoes the bending load, then you need the flexural test. Otherwise, it's not required. Yeah, corrosion research. It is very, very important, corrosion resistance, because all the material corrode, all the metallic material corrode. So understanding the corrosion behavior of this material in a heterogeneous structure is paramount importance. So the significance is very high. Elevated temperature characteristics while applying by the tensile test. Yes. So if I use the application, if I use in the applications which demands more than 300 degrees Celsius, you must do it. The hot tensile test. Okay. So again, whether it's a hot tensile test or the creep test or the stress rupture, you have to see the functionality of the part. If you ask me on the compressor blade, I would not ask you to do the tensile test. I will ask you to do the stress rupture test. Okay. Could you please explain a little more on FGM for machine tool applications? Yeah, machine tool. Take any tool which needs the toughness as well as the hardness on the surface so that life is good. Any crack comes, it will not immediately break. So I need a structure with a hard casing and soft core, okay, for the machine tool. So that's why, if you see tungsten carbide, it is infused with the cobalt, not only for the liquid phase sintering, also to introduce some amount of toughness into that. Now, if I grade that structure, it will be, very useful. So if you just give what is the insert material, I can tell you what I understand the insert material will be the tungsten carbide only. Typically, they use it. That's what I'm explaining in the GM. So need to have a toughness and the hardness optimization, gradation. From the top, hardness should be high, and when you go to the center, toughness should be high. So in between the gradient, you need to have either the linear gradient or the step gradient. So whichever the way you want to introduce, you can introduce the material. other question you can, you're welcome. Text me.
Some people are asking for the PPT if you can share.
No, why do they need PPT? I don't understand. I don't know the fancy of everyone is asking PPT, PPT. I don't understand why.
Yeah,
If you give
correct.
me the rational behind it for asking the PPT, then I can share. Just for for the fancy, just to ask is useless for either you or me. And this has some different details also which I cannot share anyway.
Correct, sir. Correct. So any
I'm
other
happy
participant?
from the many of the audience just share the PPT. What for? When you are not able to ask the questions, I give 10 minutes time. What will you do with that presentation?
Correct.
Yeah. So logic goes first.
Yes, sir. Correct, sir.
So tell your audience to be, really interested in science and engineering, and the one who questions has the curiosity for the knowledge.
Right.
So tell your audience that first,
Yeah,
rather than asking this PPT.
obviously. No. So any other question from the audience? Um, Please, you can write in the chat box. I think, sir, there is no question now.
Okay, sir. If that is the case, then we can wind up. Okay. Anyone
Uh,
wants, as I said, like any guidance, they can be in touch with me in this number what I have
yes, sir.
shown.
Number and email ID also there.
Email ID is there. I flash it to all of you once again, so they can use it.
Uh, Sir, before binding, I would request Dr. Amit Bahekar from Sage University
Yeah.
for vote of thanks.
Yeah. Sure.
Thank you, Dr. Satyan sir. Thank you very much, Dr. Ram Prabhu sir. There was a very nice session. This is very advanced topic for us. That is aircraft. We just learn lot of. So I like sir some points in the session also, that this aircraft braking system, and you mentioned the reference also, sir. That I like very much, sir. That one book you have mentioned, that is ASM Handbook of Tribology. You have given the reference, sir. So
Correct.
it was, I like this. Also, sir, you are nicely explained the material requirement of that high low wear, high melting point, wear beer gap. So I also request participant, if anybody want to pursue the PhD in the tribological sector. So yes, sir will be very definitely help us, because all the things are very nicely in advance we learned today. So on behalf of Sage University Mechanical Engineering Department, Department of Advanced Computing, I really thankful, sir, for giving a valuable time to us. Thank you very much, sir. Have a nice day.
Thank you. Thank you. So
Thank you
may I
so
take
much,
your
sir.
permission to leave?
Yes, sir.
May I take your permission to leave? I think there are no more
Uh,
questions.
no, sir.
Any questions are
Uh,
there? No, right?
no question is not there. I just want
Okay.
to thank you for
Sure.
accepting my request
Sure.
for joining in this FDP.
Thank you. Thank you.
Thank you so much, sir.
Right, sir. Right, sir. See you in the
Yeah,
next occasion. Bye.
sir. Sure,
Bye.
sir. Thank you so much, sir.
Thank you.
Thank you. So all the participants will wait for 5-10 minutes so that the second speaker will join. Gautam sir, will wait for 5-10 minutes. I will just come back after contacting the speaker.
Yes, sir.
Yeah. all the participants. Is there everyone option is not available in chat box? Actually, when you all type a chat, it directly comes to me only. Uh, when we send this message, we can select everyone in meeting option. It's on the top of the list, I think. And then in that case, the speaker can also view your message.
Remarkable. A basic communication tool has evolved into a powerful computing device that assists us in almost every aspect of life. Now let's apply it in EV also. If you go for electrical vehicles, so before proceeding for electrical vehicles, if we just compare, think about the cars we had 30 years or 40 years ago. They were mechanical machines with minimal electronics, no advanced safety systems, no automation, no smart feature. You just turned a metal key, shifting gear manually, and relied entirely on human control for everything. Now compare that with a modern electric vehicle. There is a push button to start instead of a physical key. Autonomous driving sensors are there. Then regenerative braking systems are there. A smart battery management system is there. So this transition is powerful one by one. If you go for this, then definitely there is a role of sensors. Just as a smartphones transformation, that communication transfer to smartphones. So in the same manner, sensors are transforming vehicles to a smart vehicle. Now our vehicles or our cars are more smarter, safer, and more efficient than even before. Now, the question is, why sensors matter in EV? इलेक्ट्रिक व्हीकल्स के अंदर अगर आप बात करें तो सेंसर्स की आवश्यकता क्या है? Why sensors matters in EV? So in our traditional vehicles where mechanical parts are there which did most of the work, but in EVs electronic sensors and AI driven performance and efficiency are there. So sensors are like the sense of a human body. जैसा हमारा शरीर सारी चीजों को सेंस करता है, in the same manner sensors are the thing which just as like a human body sense for the electrical vehicles. So they allow vehicle to see, to feel, to hear, and to respond to the environment. So without sensors, more electrical, without sensors अगर हम बात करें, so modern EVs won't have battery management system. उसके अंदर battery management system नहीं हो सकता है, autonomous driving नहीं हो सकती है. One of the most important feature which is known as your ADAS, that is advanced driving assistance systems, which is very useful for accident prevention. अगर वो नहीं होगा, स्मार्ट क्लाइमेट कंट्रोल उसकी बात करें, वो नहीं होगा. सो विथआउट सेंसर दीज थिंग्स आर नॉट पॉसिबल. सो फॉर बेसिक एप्लीकेशंस टू कटिंग एज इनोवेशंस, sensors are required. Now what coming in the next session, अगर हम आगे बात करेंगे स्लाइड्स के अंदर. So first we will discuss about the types of sensors in EV, what sensors are used and why, how they work, their construction, their working principle, real world applications, that how sensors improve safety, efficiency and performance. Now फ्यूचर इनोवेशंस की अगर बात करें, सो रिलेटेड नाउअडेज अगर हम पिछले कुछ सालों से बात करें, सो एआई पावर्ड स्मार्ट सेंसर्स आर देयर. which is definitely self-powered sensors and much more. So the future is here. अगर आप बात करें, so future is here. To shift from the basic cars to intelligent electric vehicles is just like the transformation of the old phones to modern smartphones. The future of transportation relies on the sensors, and today we are going to understand exactly how they work, where they are used, and what next in this particular excited field. So here is the overview of electrical vehicles. So electrical vehicles, if you go for electric vehicles, then these are the automobile powered by electronic motors instead of your internal combustion engines. जैसा कि पुराने व्हीकल्स के अंदर होता था, वी यूज देयर इंटरनल कंबस्शन इंजन, वेदर इट इज petrol based engines or diesel based engines. So it is not like that internal combustion engine. We just use electric motors instead of IC. So unlike traditional fuel power cars, EVs use rechargeable batteries such as lithium ion to store the supply energy. This eliminates the need of petrols or gasolines and significantly reduce environmental impact. EVs are become more popular due to their efficiency, lower emission, and advancement in battery technology. They offer quick operation, instant torque, and reduced dependence on fossil fuels. Now, let's look at some of the different types of EVs which are currently available in the market. The first one is your simple one, battery electrical vehicles. So these vehicles run entirely on electricity and do not have a fuel engine like if you go for the example nowadays Tata Nexon, Tata Punch, Hyundai Ioniq. These are some electric vehicles which is based on totally battery system. The second category belongs to hybrid electric vehicles. So these are mainly fuel driven but incorporate electric assistance also to improve efficiency. A well-known example अगर आप यहाँ पर देखें, so like Toyota Camry hybrid, it is one of the example of hybrid electrical vehicle. Then go for fuel cell electric vehicle. It is mainly not much popular in India. Basically, these fuel cell electric vehicles are popular in especially Germany. So if you go for this, then these electrical vehicles are in the form of fuels. They use hydrogen fuel cells instead of batteries to generate power. So the example is your Toyota Mirai. So each of these electric vehicles serves different consumer needs and driving requirements. So overall अगर आप बात करें, so we are shifting from old models to new models for sustainable transportation. Now, if you go for the importance of these electric vehicles, so we have a basic understanding of electrical vehicles. So let's explore importance of EVs in modern transportation. Your electric vehicles are transforming the automobile industry and their benefits extend far beyond just adjustment. There is a pause. Sir, I am audible?
Yes, sir. Perfectly.
So there is a power cut,
Okay.
but
No issue.
my image is not visible, but
Okay. Okay.
it's a
No
no
issue.
issue. I'm continuing with my laptop. So now we have a, if we go for
Sir, there is cracking in the noise
the,
sound.
yes, sir. Now it's perfect.
Yeah. Yes, sir. No, it's
Yes,
okay.
I'm audible.
Yes, sir. Yes, sir.
Yes. So basically, if we go for the importance, then the first thing is it is eco-friendly. So EVs produce zero tailpipe emissions, reducing air pollution and combating climate change. The second thing, it is energy efficient. Electric motors converts 90% of stored energy into motion. Whereas if you go for internal combustion engines, vehicles, they achieve, I think, as per the data, the maximum efficiency of IC is 35% to 45%. If you go for petrol-based engines, then it is approximately maximum 35%, and diesel-based engines, it is maximum up to 45%. So one more important aspect of EV is lower operating cost. So EVs have fewer moving parts, reducing maintenance cost. If you go for older models like in internal combustion engines, so in that case, lots of parts are there. But in EVs, the main part is your electric motor. The next one is your renewable energy integration. So EV can be charged using solar, using wind energy and other renewable resources. So promoting a suitable and sustainable energy future. The next one is your smart mobility. Modern EVs integrated with AI, IoT and autonomous driving technologies, making transport safer and more connected. One more important thing which we saw in India also, government initiatives. If you go for the government policies, so many countries offer subsidies, tax benefits. If we purchase EVs, then we get tax benefit and infrastructure investment to encourage EV adoption, which these benefits, EVs are becoming the perfect choice for sustainable mobility solutions, and definitely it is very important and more beneficial as compared to older transformation. Next, let's we examine some of the challenges which challenges in EV adoption. So the first one is the high initial cost. If you go for the cost analysis, then EVs are more expensive due to battery cost, although prices are gradually decreasing. The second one is the limited charging infrastructure. So lack of extensive and fast charging station can cause inconvenience for users. The next one is your range anxiety, concern about the limitations, because in petrol engines what happen or diesel engines what happen, you go for a long distance, then range anxiety is not concerned there. But in the case of battery EVs, in that case range anxiety concern is there. The next one is the battery life and recycling. So battery degradation over the time and challenge of recycling lithium ion batteries. So longer charging time is also required. Then one more concern is energy grid load. Definitely with increased EV adoption can strain electricity grids, which requires upgradation and definitely smart management in your electricity grid load. Weather performance is also one issue. EV battery efficiency drops in the case of hot and cold weather, reducing range and performance. If there is a hot weather, summer weather, so in that case also efficiency decreases. And if we go for some icy areas, so in that case due to cold weather, its efficiency also decreases. And one more important challenge is raw material dependency. Some of the materials like if you go for lithium, cobalt, nickel, which is used in batteries. So there are the limitation, because these type of materials basically allocated at that particular places where which is basically geopolitical sensitive regions. And the one most and the last one is your consumer awareness. Many buyers are still unfamiliar with EV technology, maintenance and long-term benefits. So with advancement in battery technology, sensors, AI and policy supports, EVs are becoming more reliable, affordable and widely adopted by the worldwide. But definitely some challenges are also there. Now in this slide, we will discuss the evolution of sensors in automotive technology over different eras. So first the mechanical era. Before the 1980s, during this time, vehicle relies on basic mechanical gauges such as speedometer and fuel level indicator with no electronic sensor. The next era is the electronic era. From rough 1980s to of your electronic control units or ECUs, along with basic sensors like oxygen sensor, ABS, and temperature sensors. Then came the digital and smart sensor era from the 2000s to 2010. So there is an advancement in sensors where we developed to enhance fuel efficiency, emission controls, and safety. The examples are like TPMS, parking sensors, then camera-based advanced driving assistance systems. Now we are in the era of AI and autonomous era from 2010 to present. So this era integrates AI-driven sensors, LiDAR, radar, and IoT for autonomous driving, predictive maintenance, and real-time vehicle monitoring. So looking into the future, sensors will continue to evolve, becoming smarter, self-powered, and AI integrated, enabling fully autonomous and highly effective electric vehicles. Now, if you go for classification of sensors, so let's discuss the different classifications of sensors used in automotive and EV technology. So first classification is based on the power requirement. There are two types of sensors on the basis of power requirement. The first one is the active sensor, which requires an external power source to function. Few of the example like we will cover in the later slides, like LiDAR sensor, radar sensor, infrared. So these are the sensors which require some external power. So therefore they are known as your active sensor. Some of them are passive sensors. So passive sensors are those sensors who work without an external power. They naturally detect signals such as thermocouples and microphones, which are used for temperature monitoring and sound detection. The next one, based on signal types like analog sensors, provides continuous data like your temperature and pressure sensor. The next one is your digital sensors, provide discrete on or off data. It includes proximity sensor or Hall effect sensor, which are used for detecting position and motion. Finally, the third type is based on the function. In this, the first category is your motion sensor that detect movement using accelerometer and gyroscope, which is essential for stability and crash detection. And second one is your environmental sensor, which measures temperature, humidity, and air quality, ensuring optimal cabin and battery condition. The third one is your optical sensors that detects lights and distance like LiDAR and cameras, which plays a crucial role in autonomous driving. The next one is your electromagnetic sensors, which detects voltage, current, and magnetic fields, which helps in monitoring battery and motor performance. So these sensors work together to enhance the safety, efficiency, and automation in modern vehicles. Now, role of sensors in EV technologies. So let's explore this particular one. The first one is autonomous driving and safety. So in this, LiDAR, radar, camera, and ultrasonic sensors enable collisions, avoid particular adoption, and self-driving capability. The second one is your motor control sensors. In this particular position and speed sensor optimize motor performance, energy consumption, and regenerative braking systems. The third one is your environmental monitoring sensors, which includes temperature, humidity, and air quality sensors to regulate system for passengers' comfort. The fourth one is the battery. Just wait, my power is on. Yes. The fourth one is your battery management and safety sensors. So sensors monitor voltage, temperature, and current to prevent overheating and ensure battery efficiency. The next one is your TPSM, that is your tire pressure and stability monitoring. So tire pressure monitoring system TPMS along with gyroscopic sensor improve vehicle stability and fuel efficiency. And next one is your driving assistance and monitoring sensor which is used for eye tracking, and biometric sensors detect drowsiness, stress of particular driver, and it also measures the driver alertness to enhance innovative and engineering sensors, which totally depends on your AI technology. So overall, act as the nervous system of electric vehicles. It is just like our nervous system. हमारा जो nervous system रहता है वो feel करता है सारी चीजें. So in that same manner, your sensors act as the automation and smart mobility. Now let's start one by one. The first one is your autonomous driving and safety sensors. So let's discuss the key sensors used in autonomous driving and vehicle safety. So these includes, the first one is your lidar sensor, range. The third one is your ultrasonic sensor, and the fourth one is your camera sensors. So each of one is playing a crucial role in perception and navigation. Now the first one is your lidar sensors. So before starting, just imagine if we are driving a car that can see the world also. So it's a type of a wonder. So what's the actual lidar technology does here? So lidar, which is basically stands for light detection and ranging. The full form of lidar is light detection and ranging. This just think of it as the eyes of an electrical vehicle. जैसे हमारे human being की eyes रहती है. So in the same manner, lidar is just like eye of an electrical vehicle. It sends our that particular output in the form of laser pulse, and definitely this laser pulse is invisible pulse. It is not in the visible range. It is infrared laser. So it just send out the laser pulse, measure the time taken, and bounce back and create a highly accurate 3D map of the surrounding. This makes it essential for object detection. The second one is the navigation, then collision avoidance and advanced driving assistance. So essentially lidar sensors see what human eyes might miss. हम कुछ चीजें मिस कर सकते हैं, बट lidar सेंसर उन सारी चीजों को मिस नहीं करता है, वो एक्यूरेटली मेजर करता है. Now, if you go for the construction, how do lidar sensors work? Its construction. So lidar is the combination of laser source. The first one is the laser source. So think of it as the flashlight of the system. It emits rapid pulse in the form of infrared light to scan the environment. The second part for this lidar sensor is scanner and optics. So these work like a rotating radar, directing laser beam across the surrounding. Then next part is your photo detector or receiver. This is the sensor which behaves just like ears. It listens for the returning laser pulse. Next unit is your timing electronics, which measures the time taken for the light pulse to bounce back. This helps calculate precise distance. And the last one is your processing unit. This is the brain of the system. It converts all the time and distance data into a detailed 3D map, allowing the vehicle to understand the surrounding. In this particular image, you just saw there is a scanner. Scanner is nothing but your lidar sensor, which emits light signals in the form of laser. Definitely it is infrared lasers. And after approaching to target, it bounces back to the system. And here the distance is calculated with the help of your simple formula. A distance is equal to travel time into speed of light divided by 2. Here we are taking 2 because it goes up to the target and return back to the scanner. So there for the distance is doubled. If you go for the applications of lidar, so the first one is your autonomous driving. Imagine sitting in your car, hands off the wheel, while it smoothly navigate through the traffic. So lidar enables object detection, lane keeping, and even it is able to find out the pedestrians also. and it generates a 3D mapping image. The second application of LiDAR sensor is collision avoidance. So LiDAR detects vehicle and obstacles in real time, helping cars to respond instantly. Then it is also useful for terrain mapping and road conditions analysis. So LiDAR isn't just for city and road conditions, but it also analyze road curvatures on the mountains. Even it is able to determine or detect the potholes and lane marking also. There is a parking assistance system is also included in it, and it is mainly used for battery and energy optimization. Definitely, LiDAR helps to improve EV efficiency by optimizing route planning based on the real-time traffic and road conditions. So it selects the most efficient driving path. That means less energy consumption and longer battery life. So LiDAR technology is revolutionizing electric vehicle, making them safer, smarter, and more efficient. Now, after LiDAR, if you go for next sensor, then it is your radar. So we just explore how LiDAR sensors helps, but there is a problem there. If we go for the case of LiDAR, so in the case of heavy rain or in the case of fog or snow, that's where radar sensors may work, but your lidar sensors may fail. lidar की बात करें तो बेसिकली lidar sensors के अंदर यू आर यूजिंग लाइट डिटेक्शन टेक्निक. आप वहां पर एक लेजर पल्स को सेंड कर रहे हैं जो ऑब्स्टिकल के ऊपर स्ट्राइक करती है एंड इट कम्स बैक टू द सिस्टम. सो यू आर यूजिंग लाइट रेडिएशंस, बट light radiations are affected by rainy seasons. It may be affected by fog. So the second generation or second type of sensor is your radar sensor. So radar, which stands for radio detection and ranging. It is a game changer in EV technology, definitely. Unlike like camera or lidar, radar works effectively in all weather condition. It enables real-time object detection, distance measurement, and speed estimation, making it a vital component of collision avoidance, blind spots monitoring, the adaptive cruise control. So it is much better as compared to that of your lidar sensors. So if we go for as a comparison, so it is just like the sixth sense. है ना, यहाँ पर basically you're not using direct detection technique, you are using radio detection technique. Now, if you go for the construction, a radar sensor consists of the following components. The first component is your transmitter. The transmitter emits radio waves in the form of microwave spectrum, which travel through the air and bounce off the objects. The second one is your receiver. When these waves hit an object, a car, or in a particular material, or even a wall, the receiver captures the reflected signal, allowing the system to determine what's ahead. The third unit or the third part of this particular radar sensor is signal processor. Now, this acts like a brain. The signal processor analyzes the returning signals to measure the distance, speed, and direction of the objects, helping the vehicles to make split or go for the second decision. The fourth one is your microcontrol unit. The MCU acts as the translator. It converts your radar data in the format so that ADAS may understand. ADAS, that is your advanced driving assistance system. And the last one is your power supply and enclosures. The power supply ensures uninterrupted functions while the enclosure shield it from the dust, water, and extreme conditions. So with the help of these components, our radar sensors work. Now, if we go for working principle, so before that, just imagine if we stand on a particular valley or on a particular mountain, and at that particular place, we just shout our name or say hello. I think most of the participants belongs to Madhya Pradesh. अगर आप कभी मांडू गए हो, so at that place there is a watch point, and if you you just shout hello or your name, so what happen in that case? Your voice travel hits the mountain and bounce back as in the form of echo. That is, the time it takes for the echo to return helps you to estimate how far the market your mountain is situated. आप वहां से कैलकुलेट कर सकते हैं, लगभग एक अंदाजा लगा सकते हैं कि वो पर्टिकुलर माउंटेन वैली के अंदर कितना दूरी के ऊपर स्थित है. सो योर रडार वर्क इन वेरी सिमिलर वे, बट इंस्टीड ऑफ साउंड वेव एक जो डिफरेंस है, हियर वी आर यूजिंग रेडियो वेव. सो बेसिकली it works on the function of Doppler effect and time of flight principle. So the first step in this particular, this is a process of transmission. The radar transmit or emits radio waves of a specific frequency. Then second process is your reflection. These waves travel through the air and hit object, whether it's a car or a particular object. The waves then reflect back to the radar sensor. The third step is your reception and analysis. So here in third step, there is a three part. The receiver captures the reflected wave. Then first important thing is your time delay, determines the distance. Basically it includes Doppler shift. So longer the distance, longer time required to return the wave. So definitely due to Doppler shift or Doppler effect, there is a change in the frequency or frequency shifted. So if an object is moving, the frequency of the reflected wave changes. अगर आप इसका सिंपली एग्जांपल देखना चाहें, सो इफ यू सपोज स्टैंड ऑन द रोड, सो सपोज एनी व्हीकल इज पासिंग नियर बाय अस. तो ऐसे केस के अंदर क्या होता है, सपोज देयर इज अ एम्बुलेंस, just take the example of ambulance. If ambulance is passing, so what happen in that case कि हमें उसका जो साउंड है एम्बुलेंस का, जो उसका बीप का साउंड रहता है वो ग्रेजुअली डिक्रीज हो रहा है. It is due to two reasons. One is the distance and second one is the frequency shift. One more aspect is your angle of reflection, which determines the direction. The angle at which the wave returns help the system and figure out the direction of motion. So in this way, your radar sensors work with the help of Doppler effect. Now, just like your lidar, radar sensors having the same applications, but there is some plus points also. The first one is your application. अगर आप देखेंगे, so first one is your adaptive cruise control. So radar continuously scans the road and ensure the EV maintains a safe following distance with other vehicles. If suppose any vehicle in front of the EV slows down, then system automatically adjusts the EV speed to match it. The second application is just like collision avoidance, ready for safety. Radar is constantly detecting the obstacle. If sudden obstacle appears, the system trigger automatic braking to prevent collision. It also helps in finding the blind spots. So when changing the blind spot detection, or suppose some blind spot is there when we change the lane and suddenly one blind spot is there, there is some hidden vehicle is there. So in that case, it alerts and take the decision. Then it is also useful in traffic signs and other object detections. It identifies your pedestrians, cyclists, and road signs, making driving safe. It is also useful in parking assistance. It works in all weather conditions. So if you go for a comparison, so lidar creates high resolution 3D map, but radar is reliable as a backup, which never fails. If you go for lidar, it may fail in the condition of rainy season, it may fail in the condition of fog, but at that situation radar may work. In the same category, if you go for ultrasonic sensor, the next one is your ultrasonic sensor. So imagine you are in a parking space and your EV must navigate carefully to avoid obstacle. So this is where ultrasonic sensors may work. So it is mainly used for flawless parking assistance, to detect the obstacles, and to collision avoidance. But basically, if you go for ultrasonic sensor, so the main difference in lidar and ultrasonic and radar is that ultrasonic sensors work for a smaller distance. So if you go for the construction of ultrasonic sensor, again, the part is your transmitter, but here transmitter is in the form of piezoelectric crystal. I am not going in much deep for the construction process. Like here, piezoelectric crystal is there, and if you use piezoelectric crystals like quartz crystal and apply some electric field, sounds. So think of this as the sound generator. Basically, piezoelectric crystal is used as a sound generator. It converts electrical signals into high frequency ultrasound waves. The second one is your receiver, which is known as your piezoelectric detectors. The ears of the system, it listens for the reflected sound that bounce back from the object. The third unit is your microcontroller unit, the brain behind the particular process. It calculates the distance and presence of the object. And the last one is your power supply and enclosure. Now, if you go for the working principle of ultrasonic sensor, so for that, just take an example. If suppose we are in a dark room, हम किसी अंधेरे कमरे में अगर हैं and we are not much familiar about that particular room, whether it is big or it is small, उसके अंदर कुछ सामान रखा है या खाली है, so we are not aware of that, and it is totally dark and we just want to create an image. और अगर हम उसकी कुछ इमेज बनाना चाहते हैं, हम उसके बारे में कुछ थोड़ा सा एनालिसिस करना चाहते हैं, सो व्हाट हैपन इन दैट केस? सो इन दैट केस वी जस्ट क्लैप आवर हैंड्स, हम हमारे हाथ से तालियां बजाते हैं, एंड व्हाट हैपन इन दैट केस, देयर इज सम इको रिटर्न बैक, और उस इको से हम फाइंड आउट कर सकते हैं वेदर द रूम इज एम्प्टी, व्हाट इज द साइज ऑफ द रूम, एक जनरल प्रिडिक्शन है उसके अंदर फाइंड आउट कर सकते हैं. सो इन द सेम मैनर योर अल्ट्रासोनिक सेंसर वर्क्स. It works in the same manner. So if you go for the types of ultrasonic sensor, so again it is of two types. The first one is your proximity sensors. So these helps in parking assistance and obstacle detection. The second one is your ranging sensor. If you go for ranging sensor, these are used in advanced driving assistance system, which is mainly used nowadays. जो EVs आ रही हैं या जो modern दूसरी cars भी आ रही हैं, even it is based on your internal combustion engines. So ADAS sensors are very common in that. So it is basically for range finding. It is used for range finding sensors. So if you go for working principle, so again it uses the principle of time of flight measurement. So the step one, the sensor emits high frequency sound waves, typically up to 40 kilohertz. One more important aspect, it uses the ultrasonic sound waves, because अगर आप यहाँ पर एक सिंपल सी बात करेंगे, if it emits the high frequency sound waves, then वो हमें सुनाई क्यों नहीं दे रही है? Because the ability of human ears to listen, it is just from 20 hertz to 20 kilohertz, but it is beyond that. It is up to 40 kilohertz. 40 kilohertz का साउंड यहाँ पर जनरेट हो रहा है, which is in the range of ultrasonic. So it emits that particular sound waves. So these waves travel through the air and hit a nearby object. The third step is the wave bounce back to the receiver and sensor calculates the time taken for the waves to return. So basically the principle is same as that of radar, but the only difference is that in case of radar we are using radio waves which travels with the speed of light. In case of lidar sensor, we are using laser light. Light source is there. Light source is also, if you go for the light, then speed of light is also 3 into 10 to power 8 meter per second. While in the case of ultrasonic sensors, it is a type of sound wave. So the speed of sound is near about 343 meter per second in air. So it works in the same manner, but here we are using sound waves. These are the applications of ultrasonic sensors, which is much similar to that of your lidar and radar sensors. Now one more important sensor. Imagine just driving a car, and जैसा हम पूरा environment देख सकते हैं, in the same manner वो कार भी पूरे environment को ऑब्जर्व कर रही है, वॉच कर रही है. बट द डिफरेंस इज दैट हम अपनी आंखों को ब्लिंक कर सकते हैं, हम डिस्ट्रैक्ट हो सकते हैं, बट वो जो कैमरा सेंसर लगा हुआ है वो ना तो अपनी आंखों को ब्लिंक करता है और ना ही वो डिस्ट्रैक्ट होता है, वो पूरा विजुअलाइजेशन इमेज करके दे रहा है. सो द रोल ऑफ कैमरा सेंसर्स इन ईवीज. So in the era of modern electric vehicles, camera sensors are just like the eyes of the car. It is basically used for object detection or lane tracking. It is also used for parking assistance and collision avoidance. If you go for the construction, so basically it is a camera sensor. So definitely it uses some lens system just like a human eyes. So the lens captures the light and focus it on the sensors. EVs often use wide angle lenses for surrounding view and parking assistance. Then there is a image sensor. In case of image sensors, mainly we use CMOS or CCDs. CMOS, that is your it is metal oxide semiconductors, and this CCD is your charge coupled devices. This is the core of the camera. It converts your light signals into electrical signals, allowing the car. And if we compare, CMOS sensors are mainly preferred in the case of EVs because their efficiency is more. The third one is your processor, which is mainly your digital signal processor. So the processor analyzes the capture image and enabling the object recognition, distance estimation, and motion detection. Then the fourth one is your housing and weather protector sheets. Basically, with the help of this, camera will be safe and it will work for more time. And the last one is your infrared or low light enhancement. There is some arrangement. So some EVs take it this particular feature of your night vision. So in that particular cameras, night vision is activated. So your car is able to detect in dark also. These are the applications of camera sensors: lane departure warning system, adaptive cursive controls, automatic emergency braking, parking assistance, traffic sign recognition, and driver monitoring systems. This is the comparison chart. Although we have discussed lidar sensors, radar sensors, ultrasonic sensors, and camera sensors. So these are the main autonomous driving sensors. So there is a comparison chart. Each sensor have their own benefit or maybe some limitations also. Now go to the next category. After autonomous driving, we go for motor control sensors. So in this category, there are two types of sensors: speed sensors and position sensors. Even in speed sensors, if you go for speed sensor, again, two categories are there: magnetic speed sensors, which works on Hall effect, and the second one is your optical sensors. Basically, it works on photodiodes or optical speed. The second one is your position sensors. It categorizes into three categories: incremental position sensors and contact and non-contact sensors. So we'll take one by one. Speed sensors. So if you go for speed sensor, it is not just about going fast, but about knowing how fast we are going, whether it's an airplane, calculating the speed for takeoff, or even our electrical vehicle. So for optimizing the performance, the speed sensors are required. So a speed sensor is like a car pulse monitor. It constantly measures how fast something is moving and feeds this information to the vehicle system. These sensors are critical for functions like anti-lock braking systems, which prevents wheel lockup during the sudden braking, or it is used for cruise control, maintaining the steady speed without driving input. Then it is basically electric used for electric motor efficiency also, and it is also used in navigation and safety concerns. Now, the first and the most common speed sensor is your Hall sensor. So just imagine we are driving a car, no idea about how fast we are going, no way to control your speed, definitely it's problematic. So, well, for this particular problem, there is a role of sensor. There is a speed sensor. So, one of the most advanced and widely used speed sensor is your Hall effect sensor. A very small but very powerful sensor. So, what is your Hall speed sensor? So, it is just like a small magnetic eyes. It detects a change in the magnetic field as the motor shaft spins and instantly provide speed feedback. If you go for Hall effect, then it is very simple concept. If there is a current carrying conductor placed in presence of magnetic field, then there is a potential difference across the surface of that particular conductor. It means there is a change in the voltage level. There is a change in the potential difference. So there is an image of this particular Hall sensor is there, and there is a rotating wheel, which is also known as a tooth wheel. So it detects the change in the magnetic field. So what is the purpose of this particular sensor? It detects a change in the magnetic flux and provide real-time speed feedback for precise control, work on both AC and DC motor. दोनों मोटर्स के ऊपर ये काम करेगा. If you go for the construction, so the key components is Hall effect sensor, the heart of the system, which detects magnetic field variation. The second one is your magnet or tooth wheel. It creates fluctuations in the form of magnetic field, and on the basis of this, your Hall effect sensor work. So the Hall effect sensor acts like a tiny traffic counter. It observe how often the magnetic field changes and translate it into speed data. The rotating magnet or tooth wheel changes the magnetic field. The Hall sensor detects these variations and generate voltage pulses. These pulses are proportional to the motor speed, and the motor controller calculates RPM. That is, using these pulses, the real-time data helps to control motor performance with high precision. So these are the functioning of your Hall sensors. So basically, Hall effect sensor is mainly used in BLDC motors to use in modern electric vehicle for smooth motor operations. It is also used for torque and speed control, and it is used for regenerative braking system and even ABS systems also to prevent a wheel lockup and enhance braking safety. So without Hall effect sensors, EV wouldn't be an efficient braking system, and without it, our vehicle will not be safe. So the next time, if we are driving the vehicle, and if suppose some ABS is working, anti-braking system, kept braking system is working there, a tiny Hall effect speed sensor is working behind that particular process. Second one is your optical speed sensors. So Hall effect sensor works on your magnetic field. Now come to optical speed sensor. So imagine it is a beam of light, and it is so precise that it can measure the speed of an object without even touching it. So definitely these sensors are used for the detection of speeds. So the question is that what is an optical speed sensor? So unlike your traditional mechanical or magnetic sensors, optical speed sensors rely on light. They detect the motion of tracking, interruptions or reflections of a laser, or even some LEDs are also used in it. So it is of basically two types. It may measure non. It is basically having property of non-contact measurement. In the case of Hall sensors, we required contact measurement. While this particular sensors work for non-contact measurement, the accuracy is very high, and it works in harsh environment also. Your Hall sensors may not work in dust, may not work in heat due to involvement of magnetic field, because if there is a rise in the temperature, if there is a rise in the heat due to rotation of the motor, so in that particular case there is a change in the magnetic field, and due to variation in the magnetic field, result may be incorrect. So at that particular place, your common one of the common speed sensor, which is now known as your optical speed sensors, work. So for the construction of optical sensors, we require a light source. Usually it is a LED or a laser source. Then we require a detector, and in the form of detector, we generally use photodiodes, because photodiodes having the property of detecting the radiation. Then there is a signal processor required, and its working principle is very simple. The light source emits the beam, the moving object interrupt or reflect the beam, the sensor detects the variation and generate the electric signal, and processor calculates the speed based on these signals. So this allows real time speed measurement without any physical contact. So definitely next time, if we go for high speed sensor, or if we saw a high speed train, so definitely that particular case, some optical sensors may work there. Now after speed sensors, if we go for position sensors, so there are three types of position sensors. If we classify it, so the first one is the absolute position sensors. It measures the exact position of the rotor at any given time, and used in synchronous motor and high precise applications. These sensors are critical in applications where knowing the precise rotor position is essential for smooth and efficient motor operation. The second one is your incremental position sensor. So it measures relative position change. It detects movement from the reference point, and one of the commonly used incremental position sensor is in brushless DC motors, that is your BLDC motors. Then the third one is your contact and non-contact sensors. Contact sensors, it is used for mechanical components like potentiometer. If you go for non-contact sensors, use magnetic or optical detection properties. So why these sensors are required? It enables smooth motor operation and precise control, improve efficiency in torque and speed adjustment, and support advanced features, all the advanced features which is related to regenerative braking or adaptive motor response. So as EV technology advances, position sensor continue to play a vital role in delivering precise and efficiency. So whether absolute or incremental or control or contact or non-contact, these sensors are essential in making electric motors smarter and more responsive. Now after speed sensor and position sensor, one of the most important sensor is your environmental monitoring sensors in EVs. So environmental monitoring sensors maintains a comfort and safe environment inside the cabin of the electric vehicle. So these sensors help in improving passengers' comfort, vehicle efficiency, and even regulatory compliance also. So question is, why are environmental sensors are important? So electric vehicle depends on environmental monitoring sensors to track key parameters like air quality, temperature, and humidity, both inside and outside the vehicle. So it enhances passengers' comfort by maintaining clean and fresh air inside. The second one is optimize vehicle performance by adjusting climate control system, ensure regulatory compliance by monitoring emission and air quality. It improve battery efficiency by managing temperature and humidity level. Now, if you go for types of environmental monitoring sensors, so there are two types of environmental monitoring sensors. The first one is your air quality sensors. Basically, it is a chemical sensors. And the second one is your temperature and humidity sensor. Now, one by one, the first one is your air quality sensors. So air quality sensors in EV consist of three components. The first part is your gas detection unit. It uses semiconductor, electrochemical, or infrared technology. It detects the harmful gases like carbon dioxide, carbon monoxide, nitrogen oxide, nitrogen dioxide, etc. And even it is able to detect volatile organic compounds also. The second part is the second thing is your microcontroller, which is required in each and every sensors. The third unit is your filtration and sampling. It ensures accurate detection by filtering dust and moisture. If you go for the working principle of air quality sensors, then how does it work? So the first thing is that the sensor continuously samples air from inside and outside the vehicle. Chemical reactions occurs between gases and the sensors, and there is a change in the material, changing electrical resistance. It will detect the signal. The microcontroller controller analyze these signals to determine the pollutant level. Then if pollution level exceeds a threshold, the system adjusts and air circulation activates, filtration activates, and passenger will be alerted. After that, humidity sensor is there. So in extreme temperature and humidity levels, it can affect both passenger and comfort, because when a driver is driving the vehicle for a long distance, then due to temperature and humidity level, the comfort and the comfortness of a particular driver may affect. So to ensure optimal climate control and battery performance, EVs are equipped with temperature and humidity sensors. So if you go for the construction of temperature and humidity sensors, then the first thing is your sensing element. So for temperature sensor, it uses thermistors, it uses RTDs or infrared sensors to measure temperature. Humidity sensors, it uses capacitive or resistive elements that changes the electrical properties based on the moisture content. Then microcontroller and signal processing unit is required, and protecting housing. Now, if you go for the working principle, then the first unit is your temperature measurement unit. So thermistor, basically it is of two types, negative temperature coefficient and positive temperature coefficients, or RTDs. It will measure the change in resistance with the temperature. The microcontroller unit converts this resistance into accurate temperature reading. Humidity measurement, for this, capacitive sensors are used, which detects a change in the capacitance of the capacitor due to moisture absorption, and the microcontroller calculates relative humidity and display the data. So the role of these sensors in EV is very important, and without these sensors, we may struggle a lot, and we may face the problem related to comfort of the passenger. Now, if you go for BMS sensors, in the previous slide, we have discussed temperature. In this, some temperature sensors are used like thermistors, and in BMS also, we will discuss these temperature sensors also one by one. So in an electrical vehicle, the battery management systems plays a crucial role in ensuring the safety, efficiency, and longevity of the battery. So to achieve this, BMS relies on several important sensors. The first one, for the efficiency of battery, for the maintenance of battery, basically three important sensors are there, which can measure particular things. The first one is your temperature sensors. These sensors monitors the battery heat level to prevent overheating and thermal runaway, which can lead to serious safety hazards, keeping the battery within the optimal temperature and range to improve both performance and lifespan. The second one is your voltage sensors. So these sensors measure the voltage of the individual battery cells to ensure balanced charging and prevent over voltage, which can damage the battery and reduce efficiency. The next one is your current sensors. In the same manner, just like voltage sensor, these sensors track the charging and discharging current of the battery, and this data help in power management and ensure that energy is being used efficiently. So together, these three sensors help the BMS to maintain a safe and stable battery system and ensuring better performance and longevity of the electrical batteries. Now, if we go for the working principle of these temperature sensors in BMS. So temperature sensors in BMS continuously monitor the temperature of the battery cells. It processes the data with the help of processor, then handling overheating. If the temperature rises above a critical threshold, if suppose the temperature of battery goes above 60 degree Celsius, so in that case, the system automatically trigger the cooling mechanism and it prevents the overheating and other functionality. Then important aspect is related to charging and discharging. So it monitors charging and discharging part also. Now, in this BMS sensors, battery management sensors, it is categorized in 4 parts. In EVs, it may use some type of thermistors, it may use some type of thermocouples, it may use some resistance temperature detectors, which is known as your RTDs, or more popularly, which is commonly used, your infrared sensors, which is a type of non-contact sensor. So if we discuss about the thermistor, so a thermistor is a type of resistor whose resistance changes significantly with the temperature. With the temperature difference, its resistance changes. So thermistors are widely used for temperature sensing and temperature control in BMS as well as in other automotive sectors also. So this makes them a critical part of ensuring battery safety and efficiency. The basic fundamental principle behind it, the working principle of thermistor is based on the relationship between resistance and temperature. So unlike a standard resistor, this relationship is non-linear. Basically, in the case of thermistor, we got non-linear relationship. In other type of your temperature sensors, we get linear relationship, just like Ohm's law. But in this case, we get non-linear relationship. So basically, there are 2 types of thermistors: negative temperature coefficient, which is known as NTC thermistor, and the second one is your positive temperature coefficient, which is known as your PTC. So in NTC thermistor, as temperature increases, resistance decreases. This happens because of the increase in the charge carrier mobility. More electrons move freely as temperature rises. Just opposite, अगर आप इसका देखेंगे, the second one is your PTC, positive temperature coefficient thermistor. Basically, if you go in deep for semiconductor, so semiconductors basically is of 2 types, in which so few semiconductors having positive temperature coefficient and few semiconductors having negative temperature coefficient. So in PTC thermistors, as temperature increases, resistance also increases. This is due to the reduce in the charge carrier mobility, making it harder for electrons to move. Now, if you go for mathematical model of the thermistor, so basically it use your Steinhart equation, or simplified version of it, and it uses this particular model or uses this particular equation, this relation 1 by T is equal to A plus B logarithm of R plus C logarithm of R whole cube. In this particular equation, T represents the temperature, R is the resistance, and ABC are constant specific to the thermistor material. Which type of materials are used in the thermistor? Now, if you go for the working, in the case of negative temperature coefficient, it is typically placed in a circuit as a voltage divider or as a current sensing device. As temperature changes, the voltage or current flowing through the thermistor also changes, and it measures the temperature. It is mainly used in BMS. BMS के अंदर अगर आप देखें, so in BMS and NTC thermistor is attached to the battery cells. The BMS monitors the voltage drop across the thermistor to calculate the temperature of the battery cells, and as the temperature rises, the thermistor resistance decreases. So it allowing more current to pass through, which is then measured to determine the temperature of the battery. Now, the working of PTC. PTC, that is your positive temperature coefficient thermistor, are mainly used for self-regulated temperature controller. As temperature rises, the resistance increases, limiting the current flow through the thermistor. So this effectively controls the heat generates and prevent overheating. So these are the working of your NTC and PTC. Here is a sample of your NTC, and there is a graph between temperature and resistance, behavior of your negative temperature coefficient thermistor. These are few advantages and disadvantages of thermistor. Now, if we go for advantages, so let's take a look at the key advantages of using thermistor in temperature sensing and control application. So first advantage is your high sensitivity. One of the most important feature of the thermistor is their high sensitivity to temperature changes. This makes them ideal for application required for precise temperature measurement in industries like healthcare, your automation sector, and consumer electronics. It is cost effective. So compared to other temperature sensors such as your RTTs, thermistors are relatively cheap. This cost effectiveness make them a preferred choice for large scale applications. One more important thing is the size is very small. So thermistors are compact as compared to other sensors. There is a fast response time and if you go for the disadvantages, so one of the most limitation or say disadvantage of thermistor, it gives you non-linear response. One of the major drawback of the thermistor is their non-linear resistance temperature relationship. This means as temperature changes, the resistance does not follow a simple or predictable pattern. Like just like Ohm's law. Ohm's law के अंदर क्या होता है? It gives some linear type of relationship. While in the case, this particular case, we will get non-linear relationship. So to obtain accurate temperature reading, calibration or complex mathematical model are needed to convert resistance value into temperature values. Then one more drawback is there, limited temperature range. So basically thermistor are most effective within a moderate temperature range. Exposure to extreme temperature conditions, definitely if EV is moving, it is running on the road, so the temperature of motors increases. So in that case, exposure to extreme temperature, either to high temperature or to low temperature, can cause them to lose accuracy or it may get damaged. So this makes them unsuitable for application required in that application which required precise measurement and in the case of very high temperature environment. One more important disadvantage is limited durability. Thermistors are sensitive. It is very sensitive. So if exposed to extreme conditions for extended period, then they can fail or degrade in particular their performance. After thermistor, one more important temperature sensor is your thermocouple. One of the most widely used temperature sensors across the industries, from aerospace to EVs to food processing units. These small sensor yet powerful device and help us to measure extreme temperature with remarkable accuracy. So a thermocouple is a temperature sensor that operates based on the Seebeck effect. Its working principle is based on the Seebeck effect. This principle states that when two dissimilar metals are joined at two junctions and exposed to different temperature, a voltage is generated. So it is a type of passive sensor. This voltage is proportional to the temperature difference and is used to determine the exact temperature of the environment. So thermocouple are widely used in industries, automotive, aerospace, and scientific applications due to their ability to withstand extreme temperature and provide rapid response time. Here, basically, your thermocouple classified into many categories. It is totally based on materials which is used for the construction, like type K, in which Cormel alumel is used, and range goes to minus 200 degrees Celsius to 1260 degrees Celsius. One more type is type J, in which iron constant is used, where range is minus 40 degrees Celsius to 750 degrees Celsius. In the same manner, type T, type E, type N, and type R as B. If you observe these specifications, so each sensors having different types of material and having different range, and it is not restricted to EVs only. These sensors are mainly used for industrial applications also, aerospace industries also, due to their different ranges. As we have already discussed, basically it works on the principle of Seebeck effect. So the mathematical equation for EMF calculation, it will use the thermocouple equation. The voltage generated or the potential difference output voltage measured by this particular formula. V is equal to S of difference between that particular temperature of the junctions, where S is your Seebeck coefficient, and which depends on the type of the material. If you go for advantage, so as compared to thermistors, thermocouples having the wide temperature range, fast response time, durability is high as compared to thermistor. It is self-powered, does not require additional power, compact and flexible. If you go for disadvantages, again, in this particular thermocouple sensor, it also provides non-linear output. The voltage generated is not perfectly linear, so calibration is required. Then one more limitation is cold junction compensation required. The reference junction must be accounted for the accuracy. Then limited accuracy. Now, if you go for the percentage error side, then there is some error, approximately plus minus 1 degree Celsius to 2 degree Celsius, plus minus 1 to 2 degrees Celsius of limited accuracy is there. Then there is one more limitation related to susceptibility to signal interference. So long thermocouple wires, as its size is large as compared to that of thermistors. So having long thermocouple wires, it can pick the electromagnetic interference or electromagnetic signals which is generated by the motors. So if you go for the comparison side, so thermocouples are essential tool for temperature measurement in extreme environment, but their wide range, fast response and durability, it makes them very good or essential for industrial application. But after application, there are some disadvantages also. In that particular situation, we have to decide whether your thermistor is more important or this thermocouple is more important for EVs. Then the third one, temperature detector, is your RTD. So RTDs are the temperature sensors offering high accuracy, stability, and repeatability in industries ranging from automobile, aerospace, EVs. So it is the sensor, it is the temperature sensor that works by measuring the resistance of a metal wire, which changes the temperature. This principle makes RTDs highly reliable for industrial, scientific, and automotive applications, and compared to thermocouples, thermistors having more applications. If you go for the comparison side, then these RTTs having high accuracy, then better long-term stability, and more consistent and repeatable measurements can be taken with the help of these RTDs. Now, working principle. RTD operation based on the principle of electrical resistance variation with the temperature. The resistance of metal increases as the temperature rises, and which follows Ohm's law. So if you go for particular graph, so just opposite to that of thermistors and thermocouples, RTD is having linear response. यहाँ पर हमें linear response मिलता है, and it follows the Ohm's law. So working of RTDs. So when temperature increases, metal resistance also increases. Temperature decreases, metal resistance decreases. So this predictable relationship is found in RTDs. That is, हम यहाँ पर already predict कर सकते हैं कि अगर temperature बढ़ रहा है तो उस केस के अंदर रेजिस्टेंस इंक्रीज होना चाहिए, और अगर टेम्परेचर डिक्रीज हो रहा है तो रेजिस्टेंस को डिक्रीज होना चाहिए. दैट इज वी कैन प्रिडिक्ट इट. So therefore its operation is simpler as compared to other temperature sensing devices. Then resistance measurement के लिए the RTD is connected to a Wheatstone bridge or a resistance measurement circuit. This converts the resistance change into a voltage signal. And then we required a signal processing unit. The voltage signal is calibrated using equations to determine the exact temperature. So in simple terms, heat goes up, resistance rises, the circuit detects it, and we get an accurate temperature reading. Now go for the advantages of RTD. High accuracy, can measure temperature with an accuracy of plus minus 0.1 degree to 0.5 degrees Celsius. While in the case of your thermistors and thermocouples, it is basically in the range of accuracy is in the range of plus minus 1 to 2 degrees Celsius. Then it is excellent for stability purpose. Unlike some sensors that degrade over time, RTD provide reliable performance for years. Linear response is there. The temperature rises, temperature rises, resistance rises. So the temperature resistance relationship is predictable and easy to calibrate. Wide temperature range and highly responsible or repeatable, which use repeatedly. Although after advantages, few disadvantages are also there. RTD is having slower response time. It is much expensive. The cost is more than thermocouples and thermistors due to high quality materials is used. Basically in this platinum wire is used. So as compared to traditional thermocouples or thermistors, the price rises. Required excitation current, that it is a type of active sensor, while your thermistor is a type of passive sensor. So it requires excitation current. A small electric current is needed to measure the resistance. Now the last one, and one of the most important temperature measuring sensor is your IR sensor, which is known as your infrared sensor. So just imagine to measuring the temperature of a running engine, a high speed conveyor belt, or even a human body without even touching, with the help of this particular infrared sensor, we are able to calculate the temperature. That is, it is a type of non-contact sensor for measuring of the temperature. Now, if we go for the principle of infrared sensors, so IR sensors work is based on basically two principles. The first one is the Planck's radiation formula. The first principle is related to Planck's radiation formula, and the second one is the Stephan-Boltzmann law, according to which anything above absolute zero, that is any material, any metal whose temperature is above absolute zero, that is minus 273 degrees Celsius, it emits infrared radiation. कोई भी मटेरियल है तो वो इंफ्रारेड रेडिएशन इमिट करेगा. द हॉटर द ऑब्जेक्ट, द मोर इंफ्रारेड रेडिएशन इज इमिटेड. अगर ऑब्जेक्ट को हम हॉटर साइड ले जाते हैं, सो इन दैट केस वो और ज्यादा इंफ्रारेड सिग्नल्स को या इंफ्रारेड रेडिएशन को इमिट करेगा. सो दीज टू ग्राफ्स शोज द रिलेशनशिप ऑफ स्टीफन बोल्ट्जमैन लॉ एंड प्लॉन्क्स रेडिएशन लॉ. बेसिकली इट डिपेंड्स ऑन द प्रॉपर्टी ऑफ द मटेरियल. वर्किंग ऑफ इंफ्रारेड सेंसर्स, अगर हम इसके वर्किंग की ओर जाते हैं तो बेसिकली इंफ्रारेड सेंसर्स इट इज IR, इट इज डिपेंड्स ऑन इमिशन. The object naturally emits infrared radiation based on its temperature. So we required one optical system, and optical system focuses IR radiation. So in optical system, a lens or mirror arrangement is there. Then one IR detector or converter is required. The sensor element absorbs the radiation and produces the signal proportional to the temperature. One signal processing unit is required, and for display, temperature display, output is required in this case. Now, if we go for the advantages and disadvantages of infrared sensors, so the main advantages are it is a non-contact measurement. So it is ideal for moving objects or at that places where hazardous environment is there, or high speed applications are for requirement of high speed. The second one is it having ultra fast response, can detect temperature change in milliseconds, having wide temperature range. It can measure from 50 degrees Celsius to 3000 degrees Celsius. Then durability and reliability. It works in harsh environment, including high voltage EV batteries, industrial furnace, and extreme weather conditions. Then one more advantage is no wear and tear. Since there is no physical contact, the sensor does not degrade over the time, and having high accuracy can achieve 0.1 degrees Celsius to plus minus 2 degrees Celsius accuracy, making useful in precious calculations. Although having advantages over the advantages, some disadvantages are also. The most common disadvantage is surface dependent accuracy. Basically, what happens if suppose the surface is shiny or reflective surface, it can distort a reading unless emissive correctness is applied. If there is a shiny surface or reflective surface, so in that case, the variation or the reading of the temperature may be different. Then there is an environmental interference. If suppose there is a dust, there is a smoke, there is a steam or humidity, it can block the infrared radiation and it will affect the accuracy. Then limited to surface temperature, RTTs, thermistors and thermocouples. It may be used for internal temperature of a body. But in the case of this IR sensors, IR temperature sensors, it cannot measure internal temperature of a material. And the most important thing is it is expensive as compared to other contact sensors. So although IR sensors are incredibly useful, they do require carefully calibration and right condition for optimal accuracies. So these are the 4 types of temperature sensors. Here is the comparison chart between these 2 types of sensors. What we have already, these 4 types of sensors, what we had already discussed. Now, for the management of battery, there is one more sensor which is your voltage sensor. And if you go for the voltage sensors, the voltage sensor is a device that can measure the voltage of a battery or an electrical system, and data is sent to battery management system. It ensures the battery operates safely. If you go for the basic principle, then voltage sensors work on the principle of potential difference measurement. So we required a voltage divider circuit here. It detects the voltage level across the circuits and convert them into equivalent electrical signal, either in the form of analog signal or in the form of digital signal. So a voltage divider circuit is required to measure the output voltage and to calculate the things. Just like other sensors, voltage sensors having some types based on output signals. There are 2 types of voltage signal. The first one is analog voltage signal that provides a continuous voltage signal used on basic monitoring. The second one is your digital voltage signal that converts voltage into on or off signals. And based on the measurement methods, direct sensors, capacitive sensors, inductive sensors, and optical sensors. So as we discussed these type of similar sensors earlier, so we observe that optical sensors are much better as compared to other contact sensors. Just like voltage sensors, current sensors are also there. Functionality of current sensors are just similar to that of voltage sensors. Now, one more important sensor is TPMS, which is your tire pressure monitoring system. If suppose we are going in our vehicle. And in normal days, what happen if suppose we are going and suddenly there is a puncture, there is a tire failure, and it may be due to your pressure mismanagement. It may be due to pressure mismanagement. So for pressure management, we required one sensor which is known as your tire pressure monitoring system. One of the sensor to measure pressure of air inside the tire. So a tiny high pressure sensor measure the air pressure inside the tire, and it utilize MEMS technology. MEMS, that is your micro electromechanical systems. MEMS based sensors are there, and the module is in the form of your wireless communication modules. It is in the base, it may be in the terms of your TPMS control units. So this is used for your tire pressure management. Now, if we go for working principle of TPMS, there are two techniques, there are two types. Direct TPMS, it embedded sensor inside tire and continuously measure the pressure. Wireless transmission is there. We sends data to ECU. And the second type is your indirect TPMS. No physical sensors inside the particular tire. This system relies on ABS wheel speed sensors. When a tire deflates, its diameter reduces, causing it to rotate faster. So ECU detects this description and trigger an alert. So there is a warning alert system. If normal pressure is there, then no warning system is there, and your tire are in perfect condition. If slightly low pressure is inside the tire, a yellow warning light appears on the indicator and action needed. And if there is critically low pressure inside the tire, a red warning light and an audio alert may be generated there. Then driving monitoring sensor in EV. Satyen sir?
Yes, sir. Yes, sir.
Sir, we have some time, few minutes more. I think
Okay,
it's
no issue, sir. Please,
yes,
please.
the session is
Uh,
little bit large because lots of sensors. So
okay.
I'm trying to summarize few slides.
Yeah, yeah. Sir.
So one more sensor is driving monitoring sensors in electric vehicles. So driving monitoring sensors, basically it is just like a silent hero. So these intelligent system conditionally track driver's behavior, driver's alertness, and physical condition or psychological condition of the driver to prevent accident and to ensure a safer driving condition. So basically, in these sensors, it uses infrared sensors, that is IR cameras. It is mounted on the dashboard or near the steering wheel. These cameras track eye movement and head position even in complete darkness. One more sensor is your facial recognition and eye tracking sensors. It is based on AI. So AI driven vision algorithm analyze. It expresses gaziness, direction, head tilt, detection, even some slighter movement in diverse condition. Then one more is heart rate and ECG sensors. So with the help of some PPG type of sensors, it uses the heart rate of drivers. One more sensor is breath and alcohol detection sensors. So it is hidden in the steering wheel or air vents. These sensors can detect alcohol level in breath and prevent potential risks on the road. Steering and pedal pressure sensors. So these sensors analyze grip pressure and pedal control, alert you if reaction time is slow down. So overall, if you go for driving motor sensors, so it will examine the physical and psychological condition of the vehicle driver so that alert message may be generated. So driving motor sensors, it collects the data and based on AI and machine learning system, it creates the alerts. If this particular sensors saw mild drownness, a simple dashboard alert generated. If severe drownness is generated, in that case, steering wheel vibrates or seat belt tension engages, and if critical situations arises, so in that case the car may even slow down or stop. So with these technologies like time of flight sensors, AI driven predicts models, and cloud based monitoring, the system is constantly evolving and become more smarter and more reliable. So just like this previous one, driving monitoring sensors, one more class of sensor is there, which is comes under innovative and emerging sensors. So it basically covers the wireless communication, the power sources, and the construction of the sensors based on MEMS technology. And these sensors are self-powered. It basically uses piezoelectric material that is power generated automatically. It uses thermoelectric generators and solar powered sensors that is power automatically generated, and these sensors will act as a passive sensors. So finally, thank you. Thank you very much. So we are at the brink of a revolutionary in electric vehicle technology, and where sensors are no just longer just a passive component, but it going to intelligent system that's make a vehicle smarter, safer, and more effective. As we move towards a future of fully autonomous and self-optimizing EVs, the role of sensors will continue to expand the integration of artificial intelligence, IoTs, Internet of Things, and energy harvesting technologies, and will also reduce cost, enhance and sustainability, and redefine mobility. So thank you all audience for your time and attention. Although the topic is very large and it requires some deep attention, so due to lack of time, I am not able to explain in deep. I'm just giving the introduction as per my topic of presentation, innovative applications of the sensors in electrical vehicles. So definitely in future, if we get more chance, so we'll explore each and every sensor in deep. So thank you all. Thank you very much.
Thank you very
Swami,
much,
sir.
sir.
Hello, Swami, sir. Can I have one question, please?
Yeah, yes, sir.
Yes, sir. Sir, first of all, let me admit it was a wonderful session. I attended your session and it was very informative. Sir, I have a very, actually, I have two questions, and it's a choice if you could answer these two.
Yes.
First question is, sir, how do advanced sensors improve battery efficiency and longevity in electric vehicles? This is my first question. And
Yes.
sir, if time permit, this kindly include my second question also. What role do AI and machine learning play in processing sensor data, specifically in EV performance optimization?
Yes, sir. Sir, basically what happen if we observe the functioning of all the sensors. So in that case, some optimization features are there. Then some if you go for some ranging sensors are there. Battery optimization sensors are there. So if you go for your first question, तो उसके अंदर अगर हम देखें तो बेसिकली वो ओवर हीटिंग को प्रोटेक्ट कर रहा है, वो विद द हेल्प ऑफ एआई एंड क्लाउड स्टोरेज एक ऑप्टिमल पाथ को डिसाइड कर रहा है. सो इन दैट केस वहां पर जो आपका चार्जिंग और डिस्चार्जिंग ऑफ द बैटरी सिस्टम है वो रिड्यूस हो रहा है. First thing is that. And second thing, some environmental monitoring sensors are there which monitors the battery condition. If suppose some rough environment is there, suppose heat is too much or cold is too much, so in that case what happen, the performance of battery degraded, so the system just alert. तो ऐसे केस में जो बैटरी की लॉन्गेविटी है वो इंक्रीज हो जाती है.
जी,
And
thank you, sir.
yes,
Thank you.
thank you, sir. And your second question related to inclusion of AI and IoT. So definitely in last 2 years, not in EVs, but each and every sector हमने देखा हैगा कि involvement of AI is there. And with these innovation, जितना भी ट्रैकिंग सिस्टम है, जो आपके आर्टिफिशियल इंटेलिजेंस संबंधित जितने भी आपके सेंसस रहेंगे, दे कलेक्ट द पैटर्न ऑफ ड्राइविंग. इफ सपोज समवन इज ड्राइविंग रेगुलरली, सो इट विल ऑब्जर्व द पैटर्न कि किस पैटर्न के साथ में वो ड्राइविंग कर रहा है. सो आफ्टर देन observing these particular pattern, it uploaded on the cloud system, and some algorithms are there which is based on AI technology, and definitely it will improve the driving aspects of the EV.
Great, sir. Great. I think a predictive maintenance could be managed by these things also.
Yeah,
In
yeah, doctor.
addition to, yes, sir. Thank you, sir. Thank you so much.
Thank you.
Sir, I have one question.
Yeah.
Yes.
Costa, sir.
Sir, I just want to know how do, because we know there are hundred of vehicles on the roads with the ADAS or LiDAR system, and so how these signals interfere with each other and affect the performance of the vehicle in such cases.
Yes, your question is good. Even during the presentation, I have one more question in my mind also. I will share that also. Basically, nowadays, the number of LiDARs and radar sensors increases. So, if you go for the frequency, although for each and every system, there is a set of frequency, and if it interferes, so definitely it creates some trouble. Even जैसे अल्ट्रासोनिक सेंसर्स की बात करें, तो मेरे दिमाग में जो एक क्वेश्चन आया था कि ऑल्दो आवर रेंज इज अप टू 20 kHz, but these ultrasonic sensors may affect some birds or some animals also, because some concerns are also there. Few animals are there which are able to hear the sound of 40 kilohertz or even 50 kilohertz or even 30 kilohertz. And if each and every vehicle contains these type of ultrasonic sensors or other sensors, so it may affect their hearing capability also. Just like जैसे अगर हम किसी crowded place पे जाते हैं, तो अगर हर समय वहां पर शोर शराबा होता रहेगा, सो ड्यू टू इंटरफेरेंस हमारी जो वर्केबिलिटी है, हमारा जो परफॉर्मेंस है या जो हम आउटपुट दे रहे हैं, वो रिड्यूस होगा. So your question is exactly correct. Due to interference of these type of ultraviolet, infrared sensors or radio sensors, the functionality of vehicle may be affected. So it is the topic of research. Definitely, we have to resolve these particular types of issues.
Sir, I have one more question if you allow me.
जी जी.
This like a LiDAR system, how it perform in different weather condition like rain, fogs, and because it depends on the light, right?
Yes, sir.
And so in such cases where the rainy season or foggy or snowy environment is there, at that times how it affect the even again the same thing performance of the vehicle, right? Because it is related to the safety of the people in the car. So how it is get mitigated in such cases? How they respond?
Yes, sir. You are absolutely correct. As per our discussion, जैसा कि मैंने already cover किया था, the first sensor is our lidar sensor, and after then we go for your radar sensors. And basically for lidar, these are the limitations. Although in lidar system we are using infrared radiations, infrared lasers का use किया जाता है,
Yes.
which is capable of penetration up to 300 to 400 meters. Even जैसे हम फॉग के अंदर जो हमारी विजिबल लाइट रहती है, कार्स के अंदर ऐसे लैंप्स आने लगे हैं कि हम गोज अप टू 10 to 15 मीटर्स की विजिबिलिटी के अंदर वॉच कर सकते हैं. But in lidar we are using infrared laser. So IR laser systems, it is capable to goes up to 25 meters or 30 meters. Range उसके अंदर increase हो जाती है. But for long range, although it is concern, at that in that particular situation, we have to use some type of your radar sensors are there, which uses radio waves.
Okay.
Yes.
Thank you, sir.
So thank you so much, sir. I think we should stop here. Otherwise, there is no limit for the question answer session. It's already
Yes.
9:13. So if you allow, please, can we conclude now?
Yes, sir. It's my pleasure to resolve the questionnaire session also, and
Uh, yeah, yeah. You
definitely,
all,
please, if any audience having some questions,
yeah,
so
you have already
don't
resolved
they may.
the questions. Yeah.
Yeah,
So,
thank you, sir.
with that, now I would request Dr. Rupesh Tiwari, sir, for vote of thanks. Rupesh, sir, please.
Yeah. Uh, Thank you, Dr. Satyan.
Yeah.
Very good evening to each and everyone present here. On behalf of Sage University, located at Indore, the cleanest city of India, I am very much thankful to our today's speaker, Dr. Sonu Sen sir from SNPG College, Khandwa. Sir, it has been a very, very wonderful and informative session. And you have, sir, very nicely explained the difference between the LIDAR, radar, and the ultrasonic sensors, and how the radar sensor has an edge over the LIDAR and the ultrasonic sensors. And, sir, also you have given your views on the motor sensors as well as the temperature sensors. So overall, it has been a very wonderful session, and we have enriched ourselves on the types of sensors which are used in the electric vehicle. So I am very much thankful to you, sir. And also, I am very much thankful to all the participants from all over India. And a special thanks to coordinators of this FDP, Dr. Satyan Sharma, sir, and Professor Gautam Singh, sir.
Thank you so much, sir.
So that's once again,
Thank you, sir.
thank you
Thank
very
you.
much, sir. And sir, in future also, we will be lucky if we will have contact with you. So we will be in touch regarding the different projects and the projects of the students as well as the research work.
Sure, sir.
Okay, sir. Thank you so much, sir.
Thank
Over to you, Dr. Satyan.
Yeah, yeah. So thank you so much, sir. Once again, thanks, Dr. Sen, sir. You accept my request for joining this FDP. Thank you so much, sir. So, should I now end the meeting? Huh? Sir, your mic is not unmuted. Sonu Sen, sir. Okay. So, come to the end. We'll see you tomorrow.